Hi everyone, I'm Thomas and welcome to Software with Thomas, my new channel where I am going to be doing some live streaming once a week at this time, roughly every week. And I have a little intro video on my channel if you want to check out a little bit more in depth about what this is going to be, but it's just me once a week streaming some software development related stuff, specifically focusing on game development and focusing on web development. And today we're starting with a bit of game development with Godot, a game engine out there that allows you to create 2D and 3D games, and that's what we will be focusing on today, is going through the two starting tutorials. There's one for 2D games, one for 3D games, and walking through that, making a couple games, and that'll be that. These streams, I'm going to roughly aim for them being about 3 hours, give or take. Today might be a bit longer if we're going to try to get through both tutorials, but we'll play it by ear and kind of wing it. Hopefully everything's coming through okay, sounds okay, looks okay. I was doing some tests before. This is the first stream of the channel, so you'll have to bear with me if there's any major technical issues as I'm trying to, figure all of this out. Hopefully the music's not too loud. Hopefully you can hear me okay, see me okay, and all that good stuff. I don't want to chatter on too long. I really want to hop into this. I'll just quickly note that when it comes to Godot, I am pretty much a complete newbie. I have hardly touched this at all. I have only used it for the first time last week when I completed the 2D tutorial because I wanted to be somewhat familiar with it going into this video. But I also wanted to tackle it a bit from a newbie's perspective. So I haven't done the 3D tutorial yet. So as long as we get through the 2D one in a good amount of time, we'll get to the 3D one, and we'll see what that's like from someone who hasn't not made a 3D game with Godot. So there might be a couple of learning curves along the way, but if you're new to Godot, then you can have this video as a bit of a watch along alongside these tutorials is what I kind of aim for this to be. And looking forward to doing more of these streams in the future. Like I said, once a week at this Tuesdays at this time is my anticipated schedule. And like I said, I have an intro video on my YouTube channel. I should mention I'm also going to be multi-streaming all of these to both YouTube and Twitch. So if you're watching on one, you can also watch on the other if you prefer. But since I'm just starting out, all of my past broadcasts will live on YouTube because I think Twitch gets rid of them after 7 days, I believe. So that'll be a thing. But I don't want to chitter chatter too long. I'm just going to do a real quick check to make sure everything's still coming through okay, and it looks like it is. So I think we're good to go to hop into some Godot. So like I mentioned, this is a game engine that allows you to create 2D and 3D games. Like I said before, I am pretty much completely unfamiliar with Godot. I just completed this 2D tutorial last week for the first time. But I'll real quick talk about my experiences. So I went to college for computer science. I've been programming since junior high. So programming is not a new thing for me. Game development is pretty new to me. I do have some experience with Unity that I've used in the past. I would say I'm very beginner level with Unity. Definitely I wouldn't even consider myself like intermediate with it, but I've used it a fair amount over the years, making small projects and small games here and there. But I'm trying to move away from Unity and trying out some other game engines. So today we're starting with Godot. I anticipate one of the next streams, maybe next month or so, I also want to start learning Game Maker. So that's going to be another one that I want to start learning. But we're starting with Godot because that's just the one I chose, and that's what we're going to start with. So let's hop into it. So I will, after the stream, link these in the description of the YouTube stream. I wasn't able to because I just created my channel. So apparently, like when you have a fresh channel, you can't even like post links in the comments, which I guess kind of makes sense. But I'll have to like update that afterwards. But if you just go on Google and search like Godot 2D tutorial, like this is the official Godot site. There's instructions for like the introduction and step-by-step on how to set it up. And then there's these two for your first 2D game and your first 3D game, which is what we're doing here today. So you can see there's a little picture here of the game. So I forget what it's called, like dodge the creeps is what they call it. And as you can see here, you're just gonna have this little character that moves around the screen. You have enemies spawn in, and your score is just how many seconds you survive. You hit an enemy, and it's game over. And it's a pretty simple game, but it should go through a lot of the fundamentals of how making a 2D game works in Godot. They do offer some introductory like sprites and whatnot for you to use to make it look like this. So I have already created a starting folder and I've imported those sprites, but I've not even created the base project yet. Actually, I don't even think I imported the sprites, but I have them downloaded so I can at least bring them over once we have the project created. But yeah, it says this game is called Dodge the Creeps. Character must avoid enemies as long as possible. In this, you will learn to create a complete 2D game with Godot Editor. Structure a simple game project, move the player characters, and change its sprite. You'll be able to spawn random enemies and count the score plus more. Why start in 2D? Well, if you're new to game development or unfamiliar with Godot, we recommend starting with 2D games. This allows you to become comfortable with both before tackling 3D games, which tend to be a bit more complicated. And that's why we're going in this order today. That's pretty much it. So we're going to just hop into the content. So you can see here, it's got like a couple chapters to it. So we're going to be setting up the project, creating the player scene, coding the player, creating the enemy, the main game scene, heads up display, and then finishing up. So setting up the project. And what I also have is I have a second monitor that I'm just going to have this on so I don't have to, I will be flipping back and forth between the two, but then I'm going to have it up on my other monitor so I can like reference it and not have to flip back and forth as much. So the first part is setting up the project. You launch Godot and create a new project with the new button. When you're creating a new project, you need to choose a valid path. So you basically just need to choose an empty folder. So I have Godot opened here. You can see completely blank, clean canvas. So we're going to create a new project. We're going to browse to, I have a workspace, Godot, tutorials, first 2D game, and that's the folder we're using. And I'm just going to call it first 2D game. And create and edit. That should launch it. I guess it launched it on my other screen, but I'll drag the window back. Maybe if the window wants to drag. There we go. Make that nice and big. And we're looking good. So first step done. We're on our way to making this 2D game. So the next thing is this game is designed for portrait mode. So we need to at least adjust the size of the game window. And you do this by clicking on project and project settings. Then there's a display portion on the left-hand side with a Windows tab. You click on that and you can change the viewport width and height. So we need it to be 480 by 720. Okay, is this going to be annoying? Maybe I'll have to like tab between them. Seems like it's a little annoying about that. So, let's click on the project and then it's up at the top, duh. You can't see, but I have like my Mac bar at the top. There's project, and then you can click on project settings. That opens this up, window display, and that needs to be 480 by 720. Boom, done and done. Go ahead and save that. I don't know if we really need to save it. No, I'm gonna open it back up just to make sure it's saved properly, and it did. There's a couple other settings we have to do. So under the stretch options, which is down here, it says to set the mode here under stretch to canvas items. So done and done. And then aspect, it needs to be set to keep. This ensures the game scales consistently on different size screens. And that's all it seems like we have to do setting up the project settings. Once again, I'm going to save, make sure we're saving often. It's always a good suggestion when you're programming or coding or really working on anything on a computer, save often. And definitely having like backups, like using version control is also good if it's a bigger project, but for a tutorial like this, not super necessary. Okay, so we'll hop back to the actual project, the page here, the tutorial. In this project, we will be making 3 independent scenes. We'll have the mob scene, the player scene, and the HUD screen. We will combine that into the game's main scene. In a larger project, it might be useful to create folders to hold the various scenes and scripts, but for this relatively small game, you can save your scenes and scripts into the project's root folder, which is identified by res://. You can see the project's game folder in the system. With all this in place, you're ready to design the player screen. So as you can see here, they have art fonts and icon. So I will quickly, the only thing we have in ours is icon. And that's because the fonts and art is from the downloaded stuff. So I will quickly import that. That was on the first page, and yeah, there we go. All in there. So now we're ready to move on to chapter 2. We're cruising right along. Creating the player scene. So with the project in place, we can start working on the player controlled character. The first scene we will define is the player object. One of the benefits of creating a separate player scene is that we can test it separately even before we've created other parts of the game. So this goes over the concept of node structure. So to begin, we need to choose a root node for the player object. As a general rule, a scene's root node should reflect the object's desired functionality. So of pretty much what the object is. So you click on other node, and then we'll add an area 2D node to the scene. So let's go ahead and do that. So we go to here, click on other node, type in area 2D, boom. It's as simple as that, really. It doesn't say to do this, but I want to go ahead and save this as the player scene. Once again, I'm just the kind of person that likes to save often. I've been burnt by stuff just crashing and losing progress. So yeah. So Godot will display a warning sign in the icon, next to the icon, but you can just ignore it for now. We'll address it later. So with area 2D, what that does is we can detect objects that overlap or run into the player. So we need to change the node's name to player by double clicking on it. And now that we set it as a scene's root node, we can add additional nodes to give it more functionality. So let's go ahead and make this called player. I don't know why the switching between these two is being so weird. Like I said, first stream, figuring stuff out, so you have to kind of bear with me as we have some minor technical difficulties along the way. So that's named player. So before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on them. So what we have to do here is select the player node and then click on the icon to the right of the lock, which is right here. If you hover over it, it says group selected nodes, and it just makes selected nodes children not selectable. So we just click that, and that's all we have to do. And then let's go ahead and save the scene. So now we get to go down to, which this is the part we just did. Like I said, I have this off on the side, so I'm not gonna be maybe going through all of it on screen. I might kind of be doing that half and half stuff. But now we're going to sprite animation. So we got to click on the player node and add a child node called animated sprite 2D. The animated sprite 2D will handle the appearance and animation of our players. Notice that there is a warning symbol next to the node. An animated sprite requires a sprite frame resource, which is a list of animations that it can display. So to create one, find the sprite frame property under animation tab on the inspector, click empty, new sprite frame, click again to open the sprite frame panel. So let's go through that real fast because that was kind of a lot. I need to just tab between these two because clearly doesn't like me just clicking like that, I guess, for some reason. So click on the player, and you can either, there's a couple ways you can add a node. I'm pretty sure you can just click the plus here. But what I like doing is just, I'm on a Mac, so I could do Command A. I'm sure that's Control A if you're on Windows or Linux. And we need to add animated sprite 2D. So where is that? Let me go sprite 2D. There it is. Animated sprite 2D. Add, boom. As you can see, like it mentioned, there is a little warning symbol there, but that's fine for now, because then we can click on this and find the sprite frame property over here, which I believe that's under animation. Yes. So we got to go into the animation tab, sprite frame, and what we're doing is clicking new sprite frame. And then like it mentions, you just got to click it again, and that opens the sprite window down here, which my camera's blocking a little bit. And maybe I'll go ahead and move my camera to the other corner because I think that might be a little bit better for Godot. So let me just move this around. Normally I like, it seems like the top left corner is the best, but I think specifically for Godot, like that's gonna be blocking a lot of stuff. So yeah, I think down here should be a little bit better because you can at least see this part and, you know, the file structure and all that stuff. Okay, so now we have a animation frame area that we can start adding animations. So On the left here is a list of animations. You can click the default one and rename it to walk, which we'll go ahead and do. And then we can click add animation button, which is this one right here, or it looks like you can do Command N and add a second animation called up. So then we find the player images in the file tabs. They're in the art folder. So we open this up, boom, we got 2 for up and 2 for walk. And you just drag the 2 images for each animation into this proper animation. So since we're selected on the up animation, we click these 2, drag them over. That's all we do. We click on walk, grab these 2, drag them over. That's it. It's great. Animation is coming along. So this little section is what we just did. So now the player images are a bit too large for the game window, so we need to scale them down. So if we click on the animated sprite 2D node and set the scale property to 0.5 and 0.5, that's kind of what we need to do. You can find it in the inspector under the node 2D heading. So let's go ahead and do that real fast here. So we need to click on the animated sprite, node 2D, scale right here, and we want to make it 0.5 by 0.5. It's kind of, this little lock symbol here just means that the component like ratio is locked together. So you saw, even though I didn't change the Y scale, it automatically changed it for me. You know, we've done a bit of work. Let's save. So the last step here is to add a collision shape 2D. As a child of the player, this will determine the player's hitbox or the bounds of its collision area. For this character, a capsule 2D node gives us the best fit. So next to shape in the inspector, click new capsule shape 2D and use the 2 size handles, resize the shape to cover the sprite. When you're finished, the player scene should look like this. Make sure to save. It's always important. And in the next part, we'll add a script to the player node to move it and animate it. Then we'll set up collision detection to know when the player got hit by something. So let's go ahead and switch over and do this and add the collision shape. So we go to the player. Make sure you clicked on the player, not the animated sprite. Add, and we're going to add the collision shape 2D, which is just that one. Making sure that's all good. Done and done. Then we need to change the shape of it. So over here under the inspector on the right, you can see there's the shape box and it mentioned the capsule shape 2D is what's best. So now we need to resize it to fit our sprite, but where exactly is our sprite? Well, up here you can click center. Great. Now it's really zoomed out. So let's zoom in a whole heck of a lot. And there we go. Now we can actually see them. And it says to use the handles to resize. So let's go ahead and do that. So we want to, probably doesn't have to be too exact, but we want to get it pretty close. It looks good to me. And we are done with this step. And our player scene looks exactly how the guide mentioned. So with that, we're ready to move on to the next chapter of coding the player. I'll take a quick sip of coffee here. We are cruising right along. Yeah, so let's see what we got to do next. So in this lesson, we'll add player movement animation and set it up to detect collisions. To do so, we need to add some functionality that we can't get from a built-in node. So we'll have to add a script. So you need to click on the player node, make sure it's the top one, and then click attach script button. In the script window, you can just leave the default settings alone, click create, which is the script window. There's some notes here. So if you're creating in C# or other language, you make sure to select the language you want to use. If this is your first time encountering GD script, there's some scripting language docs that you can read. But I think the GD script is pretty straightforward. It is pretty close to C#, but it's not because C# is like a different option here. But I think, this tutorial keeps the code very simple. I mean, like I said, I just did this last week for the first time, never having touched GD script before, and I think it was pretty easy to understand. So, and it kind of walks you through step by step. It explains some of the functions it uses along the way, but having previous programming and scripting knowledge will definitely help just you be familiar with some of the concepts going on. But let's go ahead and add this. So click on the player. Up here, you can attach a new script. Like I said, keep everything by default and click create. Now, one thing that tripped me up when I was first going through this tutorial that I'll quickly mention is up here at the top. Notice that there are a couple different tabs, which I guess my little top bar is hiding. So I'm gonna quickly move this down for just a second, maybe. Can I? Okay. So you can see here, okay, now I'm all thrown off. Let me do this. Actually, give me 1 second. I'm moving stuff around just for 1 second. Okay. I can see here my little top Windows like stream overlay is kind of blocking this, but there are a couple of buttons at the top. So right now, since we create a script, we're now on this like script tab. That's something to keep in mind. I didn't know this existed and I was very confused. I was like, how do I get back to my player? You just click on the 2D part and boom, we're kind of back where we were. Click on the script, we're back on the script page. So it's something to keep in mind. Kind of tripped me up the first time, but once you know it's there, it's not too bad to kind of navigate between. But here we go. We got a script attached to the player. It's just called player. And we're gonna start adding some stuff to it. So let's go ahead and look at the first bit of code we're adding. I guess I gotta switch back here. So we start by declaring the member variables that the object will need. So this extends part starts at the top. So the first thing we're adding is this var speed equals 800 or 400. Var is just a variable. And export, what does export do? Well, using the export keyword on the first variable speed allows us to set its value in the inspector, which is pretty dang handy, as it says here. This could be handy for values you want to be able to adjust, like a node's built-in properties. So you can click on the player node, and you can see that the property will appear in the script variables part on the right-hand side, and you can change the value here, and it will overwrite the value written in the script, which is pretty dang handy. And then we're also adding a screen size, which we're not exporting because that's not really something we need to be changing in the inspector. So let's go ahead and add this in and we'll see what it looks like. So extends area 2D is already at the top. So first we will add in export and var speed equals 400. And then the thing below that is var screen size. You will have to excuse my typing. I mean, first off, I'm not really the fastest typer or the best typer, but also last week I just got a new keyboard, so I'm still getting used to it. So I do apologize for the slow typing and the occasional typos we'll have along the way. But I think for a lot of the times we're going through a tutorial, not typing super fast is probably better anyway, but maybe that's just me coping. But yeah, like I said, new keyboard, still getting used to it, so I apologize for the not great typing speed and accuracy. But yeah, we added our variable speed here. We exported it, added the screen size. Haven't done anything with that yet. And then as you can see here on the right, under player GD, you can see the speed, and it's set to 400, and we can change it around if we so please. So next up, let's switch back to the tutorial. Did all this, we see this. So the player script should already contain a ready and a process function. If you didn't select the default template above, create these functions while following the lesson. So the ready function, as it says here, is called when a node enters the scene tree, which is a good time to find the size of the game window. So in the ready function, we're setting the screen size, and we're running this other function called get viewport rect, and then setting it to size. So I'm just gonna copy that. I'll type it out. So let's go ahead and do that first, and then we'll do the next part. So ready, as you can see here, both of these are in place if you just initialize the script like you're told, and it has just pass in there, which just basically means nothing's happening. It's just kind of a blank function. So let's add in the screen size, which autocompletes equals get. You can see there is some autocomplete, which is nice. I could just tab, boom, get viewport rect. I type dot. You can see it just lists a bunch of stuff here. So I just type S, tab, and it gets the size all in there. As you can see, it also does error checking along the way. So it was red there for a bit, but once I finish typing, you give it a second, we're good. Error goes away. So that's it's a very nice feature to have. So all right, setup script, or the ready script is done. Now we can use the process function, which will define what the player does. So what does the process function do? Well, it's called every frame. So we'll use it to update the elements of our game, which we expect will change often. For the player, we need to do the following. We need to check for input, move in a given direction, play the appropriate animation. So first we check for input. Is the player pressing a key? For this game, we have 4 directional inputs to check for. So input actions are defined in the project settings under input map. Here you can define custom events and assign them different keys, mouse events, or other inputs to them. So for this game, we'll map the arrow keys to the 4 directions. So we need to go back to project and project settings to open the project settings window. Click on input map tab at the top and then type move_right. In the top bar, click add, and this will add the move right action. To assign a key, then there's this little plus button. You just click that, and then it will say listening for input. You just press the right key on your keyboard, and then it will kind of just fill that in for you. Click OK, and now the right key is associated with the move right. And then we need to do that 3 more times for move left, move up, move down. And by the end, our input map area should look something like that. So let's go ahead and do that real fast. I'm just gonna make sure I'm caught up on my other monitor here. So project settings at the top, input map over here, add new action. We're calling this first one move right. Click add, and then once it's here in your actions, you click the add button on the right, click the right arrow, you see it fills in, you click OK, that's it. Go ahead and do move left and add that, add the key for the left, done. Move up and add the key, click up, done. And then last one, move down and add that, add the key, boom, done. And now our inputs look exactly like the thing shows, so we can go ahead and close this out. I'm gonna go ahead and save, not that we don't necessarily need to, but you know what? It's something I like doing. I'm gonna take a quick sip of coffee here. We are flying through this tutorial. We got past the easy stuff. Some of the more difficult stuff is coming up where we have to start dealing with movement and inputs and animations, and then we gotta, but it's fun stuff, it's all part of the fun of creating games. So we did all this, click close. And one thing that it notes here that's pretty important to mention is we've only mapped 1 key to each input, but you can absolutely map multiple keys, joystick buttons, or mouse movements to the same action. So if you're a classic gamer and you're used to the WASD, you could also add those as additional inputs for up, down, left, and right. Or you could use the arrow keys and kind of have both as an option, which is kind of nice. Or like it mentions, you can add joystick buttons. So if you want to have controller support, there you go. Or mouse buttons, there you go. So now we can detect whether a key is pressed using this little function, which is input.isActionPressed. And then inside the parentheses here, we just add in the action name, which as you can see here will be either move right, move left, move down, move up. And it will just return true if it's pressed or false if it isn't. So what we're doing here is we have the process function that, once again, as it mentioned earlier, runs every frame. It's how we're going to handle a lot of the main portion of the player object, the player scene, the player script. So first we're defining a variable called velocity and setting it to 0. This vector2 is just how it kind of handles movement in this. So vector2.0 is just 0, 0x and 0y, just making sure it's 0 in any of the directions. And then as you can see, we just check, is the movement right? If it is, we add velocity.x plus 1. Is it left? Velocity.x minus 1. If it's up, y plus 1. If it's down, y minus 1. And then at the end, we check, is the length greater than 0? And then if it is, velocity will equal velocity.normalize times speed. And then we do animate sprite 2d.play, else animate sprite 2d.stop. It's kind of a lot. And right here below, it does a good job of explaining some of this. So let's quickly talk about it before we hop into coding it. So We set the velocity to 0, 0. It kind of just does coordinates. That's what vector does, because the player should not be moving. Then we check if the input, and we add or subtract the velocity. If you hold right and down, the resulting velocity would be 1, 1. So it kind of allows for diagonal movements. In this case, we're adding horizontal and vertical movement. The player would move faster diagonally than if they just moved horizontally. Yeah. We can prevent that if we normalize the vector, which means we set its length to 1, then multiply by the desired speed. This means no more fast diagonal movements. So that's what the whole normalized part does, is it normalizes it and then times it by the speed. Then we could check if the player's moving, and if so, we call play or stop on the animation, which is how you animate the sprite. As it notes here, this $ is used frequently in Godot, and we'll be using it a decent amount in this tutorial. So what exactly does that mean? So it's shorthand for the getNode function here, and getNode just, well, I'll explain it here in a second, but so in the code, animatedSprite.play with the $ at the front is the same as getNode animatedSprite2D.play. In GD script, $ returns the node at the relative path from the current node, or returns null if the node is not found. Since animatedSprite is a child of the current node, we can use $animatedSprite. And that's the explanation for that whole bit of code. It's kind of a lot. So I mean, I'm just gonna paste it in since I talked about it. Don't need to see me type this all out because it's all the same. Yeah, we're just setting the velocity to 0, adjusting the velocity based on the inputs pressed. If the velocity is greater than 0, we're normalizing it first, and then timesing it by whatever our speed is, which is the variable we set at the top. And then we play the animated sprite. If the velocity is greater than 0, or if not, we stop the animation. And that's that. So let's cruise right along to the next section. So now that we have a movement direction, we can update the player's position. We can also use clamp to prevent it from leaving the screen. Clamping a value means restricting it to a given range. So we can add the following to the bottom of the process function, make sure it's not indented under the else. So what we're doing is adding, we're taking the position variable and adding velocity times delta, and then position will be equal to position.clamp, 0, and screen size. So yeah, like it mentions, clamp just kind of gives it a range, so between 0 and the size of the screen. And the delta parameter refers to the frame length. So it's the amount of time that the previous frame took to complete. Using this value ensures that your movement will remain consistent even if the frame rate changes. So that's what that little bit of code does. So where did it say to add that? At the bottom of the processed function. So we did that down here. Like it said, make sure you're not indented under the else. Add that in. Let's get our indentation all proper. And I think we're good. Now, one thing I'm curious about, I'll make sure I didn't miss something. Because I don't know, we didn't define a position variable. That's kind of odd. Because we're just setting position. Oh, I think position is just like, it's just part of player. It's not like a variable. I just noticed that now. Okay, well, you know what it says to do now? It says to test it, and let's see if it works. So we click play scene up here. You can also, what does it say? You can do F6 or Command R on Mac to run this. No main scene has been selected. Let's just select current, because that's what we're on. A little window pops up. Got to give it a second to load here. It's the first time it's loaded, so it seems like the first time you run this, it usually takes a second, even for a small 2D game. But you can see our player up there, and look at that. Left, right, up, down, and as we move, you can see the little walking animation going on. Now, it's not the correct animation, and that's something we're going to deal with here in a second, but hey, and if I try to move off the screen, you just can't. It lets you kind of partially move off the screen, but then it stops you, and that's the clamp function coming into play. So Cool. We have a working, moving player, which is kind of cool. So let's move on to choosing animations. So now that the player can move, we need to change which animations the animated sprite 2D is playing based on its direction. So we have the walk animation, which shows the player walking left to right. This should be flipped horizontally using the flip H property for left movement. We also have the up animation, which should be flipped with this function called flip V for downward movement. So let's place this code at the end of the processed function. This is some not too crazy of code. So you're checking if the velocity for X, remember velocity is just kind of which way you're moving and how much you're moving. So velocity of X, which is the horizontal, if it does not equal 0, then the animation equals walk. That means we're moving left and right? And then we set flip vertical to false because flip vertical is what's used for down here. So we want to make sure it's not flipped. And then we do this flip horizontal or flip H, and we set it equal to velocity X is less than 0. And this is a cool little shorthand. And there's a little note down here that the Booleans are assigned with a common shorthand for programming. So what we're doing is called a comparison test and also assigning a Boolean value. We can kind of do both at the same time. So this code up here is equivalent to this code down here. So this is just assigning flip H of velocity.x is less than 0. So if it is less than 0, it's going to be true. If it's not, it's false, which is essentially what this is. It's checking is velocity x less than 0. If it is, set it to true. Else, set it to false. So this is just a shorthand for this if you've never seen that before. But like it mentions, this is a kind of a pretty common thing in programming these days. So, I mean, depending on what language you use, but it's something to be familiar with because it does save some code space. As you can see, you just do it right here. And what this takes 4 lines and a lot more text to do. And then this part down here handles the up-down movement. So if there is a Y direction velocity, then we change the animation to up, and the flip vertical will then be the same thing where it checks if the velocity is greater than 0, and if it is, then the flip vertical will be true or else it'll be false. Pretty nice bit of code. We're adding this at the end of the process function. So let's go ahead and I just copied and pasted it, but gotta be careful when you copy and paste because sometimes the indentation will be messed up like that. So let's go ahead and fix that. The errors should go away and boom. It's all the code we just went over. I will click save and run the scene again. And there's our character. So you can see the little eyeball. It might be hard to see, so I can, since we set the aspect earlier, we can change this and it will kind of retain all the aspect properly. So yeah, you see when we move left and right, see if we're moving to the left, the eyeball's looking left, moving to the right, eyeball's looking right, going down, eyeball's looking down, moving up, eyeball's looking up. So it seems like the animation is all working as it should be. And that was not that much code. Some of it is definitely a little confusing, but once you get the hang of it, it's not too bad. And yeah, animation, I think is just, we're pretty much done. So one of the last things we're gonna do then is under the ready function, we're gonna call the hide function. And what this does is essentially just hides the player. So we don't see them when the game starts. Because when if you saw that little preview at the beginning of like the GIF of the game playing, it starts at like a main menu screen. So you don't want to see the player or be able to control the player while you're at the main menu screen. But once you click start, then the player will appear. So you want them to actually start out hidden, and that's what this hide function does. Okay, we are almost done with this section. We just have to, with coding the player, really the last thing we have to do is collisions, which, see, there's a fair amount here, and this is going to get into signals and whatnot, but signals are pretty cool. And yeah, we'll just go over this. So we want the player to detect when it's hit by an enemy. Well, we haven't made any enemies yet, but that's okay, because we're going to be using Godot's signal function to make it work. So add the following line to the top of the script if you're using this, yada, yada, yada. If you're using that, this needs to be at the top. And we're just adding something called signal hit. So let's go back, top of the script. We'll add it right at the very top, signal hit. Just like that, super simple. This defines a custom signal called hit that we will have the player emit or send out when it collides with an enemy. We will use the area 2D to detect the collision. So what you do is you select the player node, click on the node tab in the inspector on the right hand side, and then you'll be able to see a list of signals the players can emit. And as shown here in this little box, notice our custom hit signal is there as well. Since our enemies are going to be rigid body 2D nodes, we want the body entered signal. So this signal will be emitted when a player or when a body contacts the player. So what you do is you click on this, you click connect, and the connect signal window will appear. Godot will automatically create a function with the exact name in the script for you. You don't need to change anything right now. And you'll see something like this that'll say on body entered, and it'll have a little green icon next to it. So what's that green icon? The green icon indicates that a signal is connected to this function. This does not mean the function exists, only that a signal will attempt to connect to a function with that name. So double check that the spelling of the function name matches exactly. Kind of a lot, but it's not too bad, I promise. So we have our player selected over here, and we click on the node tab over here in the inspector. And over here you can see our custom hit node, which is great, but what we want is the body entered, which is this. So we double click that, and as I mentioned, this signal window pops up. Great. We want to leave everything as is. Don't touch anything, just click connect, and boom. Right at the bottom, you see here, it creates that function on body enter, and it has the little green arrow there that shows this is hooked up to something. You can also see on the right-hand side under the signal, it shows the on body enter function. Pretty cool. Let's hop back and add code to the function. So on body enter, we take in the body that connects with our player, that enters our collision. We do a couple of things. It doesn't look like we really actually do anything with that body, but we at least at the moment. We first hide the player, so the player disappears after being hit. We use our custom emit that we just made, and our signal, and we emit it. So hit.emit. That's how you kind of emit your own signals, which is pretty neat. And then finally, we grab the collision shape 2D, and we set deferred. Use the function set deferred with disabled and true. So what exactly is going on here? So it says must be deferred as we can't change physics properties on a physics callback. Okay. Each time the player an enemy hits the player, the signal is going to be emitted. We need to display or disable the player's collisions so that we don't trigger the hit signal more than once. So, and there's a little note explaining this a little bit more, that disabling the area's collision shape can cause errors if it happens in the middle of an engine's collision process. So use set deferred tells Godot to wait to disable the shape until it's safe to do so. So definitely a little confusing, but that's kind of what we need to do is add all of this in. That's going to hide. It's going to emit our custom signal, and then it's going to set deferred, disabled, and true to essentially disable the player's collision is what that's essentially doing. So we replace this pass with our new code and click save. And then the last little step is that, we got to update the start function. So the last piece is to add a function that we can call to reset the player when starting a new game. So we're going to call this start. We take in POS, which doesn't stand for what you think. It stands for position, not point of sales. And we set position to that. We do the show function, and then we grab the collision shape and set the disabled property to false so that it's enabled. It's kind of weird, but that's just how you do it. I don't think it really matters where you put this, so I'm gonna put it. I'm just gonna put it at the bottom, I guess. I don't know. Or you know what? No, I'm gonna put it above. Yeah, like right here, above the signal functions. And there we go. We have a start function that, when the game starts, we call this to set the position, show the player, enable the collisions by setting disabled equal to false, which is kind of, it seems like a little, not backwards way to do it, but maybe, I guess that's the way to do it here. I don't know. I guess there's just no enabled or disabled. Well, there is, but then you have to set it to false. But whatever. We're moving right along. We're on creating the enemy. We're over halfway through this tutorial, so we're making good progress. I'm going to take another quick sip of coffee here. Hope y'all are enjoying this so far. Maybe learning a thing or two. I know Godot, like I said, is new to me, so this is all pretty new to me, but I think this tutorial does a good job of walking you through it, and hopefully me walking through it in video form also helps if you're someone new to it like me. But I will say that the 3D one will probably take longer. We might not fully get it done, and I'm going to be going a lot slower through it. Not a lot slower, but a fair amount slower, just because I haven't even done that. I might be making mistakes along the way. But yeah, we're going to go ahead and hop to creating the enemy. So now it's time to make our enemies. Our players will have to dodge. Their behavior will not be very complex. The mobs will just spawn randomly at the edge of the screen, choose a random direction, and move in a straight line. That's it. So first we need to create the mob scene, which we can instance to create any number of independent mobs in the game. So click scene and new scene at the top, and then add in the following nodes. So we create a rigid body, name it mob, and then childs under that node, we add animated sprite 2D, collision shape 2D, and we've seen both of those so far. And then we add visible on screen notifier 2D. Okay. And don't forget to set these as children, set the children so they can't be selected like you did with the player scene. So let's go ahead and do all that first, and we'll hop down to some of this other stuff here. So we will go to scene at the top, which my thing is kind of hiding, but I'm clicking scene, click new scene. I'm gonna go ahead and just immediately save this. I guess I can't yet. So we're going to then add an other node. And the first main node we're adding is rigid body 2D. Adding that, we need to name it mob. And then we also need to save this as mob. Then we need to, see, this is like one thing that threw me off, because you have to go back to the 2D. With this clicked, then you click on this button next to the lock that locks the children from being selected. There might be a way to do it here. I guess not. So you got to make sure to do it that way. But let's add the children to this. So with this selected, I'm going to do Command A, pulls up the new node window, and we're going to first add the animated. I don't know why that doesn't sprite. Animated sprite 2D. First one done. Re-click on mob. Let's add a node this way. Just click the plus button. It all does the same. Collision shape 2D added, and then we click on mob again, add again, and the last one is visible on screen, not enabler, but notifier 2D. Add that. Cool. Let's go ahead and also, while we're at it and on the scene, let's center it and zoom way in so we can see a little bit more. Maybe that's too much. We don't have a sprite yet, so there's really nothing to see, but I like just having that set up. So now, let's hop back to the tutorial. Select the mob node and set its gravity scale property on the rigid body 2D section of the inspector to 0. This will prevent the mob from falling down. In addition, under the collision objects section, beneath the rigid body 2D section, expand the collision group and uncheck the 1 inside the mask property. This will ensure that mobs do not collide with each other. So let's do that. So click on mob over here. We have our node window open, but we can just click on inspector, not a big deal. And first thing was setting the gravity scale to 0, which you can see here is just a little area. We can add that, boom, easy enough. So in addition, under the collision object 2D, which is right down here, that's not the collision shape 2D, it's the collision object on the mob node. We can go to the, was it the collision section, right? Yeah, just beneath that, expand the collision group, uncheck the 1 inside mask. Seems like layer we don't uncheck, just the mask one. And that's that. Was there not a third thing? I feel like I'm forgetting something. No, we did the gravity scale, we did the mask. So now we need to set up the animator frame, or the animated sprite like we did with the player. So if you don't remember how we did that last time, click on the animated sprite shape. Under animation, sprite frame, new sprite frame. Re-click on the sprite frame, opens the frame window down here. And this time we're adding 3 animations, fly, swim, and walk. So we're adding fly, enter, new one, swim, enter, last one, walk. And then like before, we are going to add the 2 images which are in this art folder. So you can see we got flying. We'll add that to fly, swim, and walk. Simple enough. Now we're doing something a little bit different this time. Slight change is that the animation property has been set for each individual sprite. So what we want to do is adjust it to 3 for all 3 animations. Pretty straightforward thing to do. It shows you right here it's highlighted. So this FPS, we just want to bump that down to 3. And like it says, it's for individual sprites. So you need to make sure and go through and do that for all 3. Boom. Done. Simple enough. You can use the play animation buttons on the right of the animation speed input, which is right here, to view the animations, right? To preview your animations. Yes, you can click play. There's the fly animation. Let's take a look at the swim one. Okay, and then finally the walk one. Nice. Okay, as you can see here, I was just clicking the little play button there. The stop button becomes pause once it's going. But yeah, that's that. Great. So like the player images, these mob images need to be scaled down. So what we need to do is click on the animated sprite, which we already have selected. Go over here to the inspector under the I think it's the transform. Yeah, we need to set the scale of the animated sprite 2Ds to 0.75 and 0.75. So let's set the X 0.75, enter. And since these are linked, the component ratio is locked, I guess is the proper term. It already shrunk the Y value down to 0.75. So we're good. So as in the player scene, we also need to, I can just hop back to the tutorial, but I'm just essentially reading this part. So as in the player scene, we need to add a capsule 2D for the collision. To align the shape of the image, you'll need to set the rotation property to 90 degrees. Okay. So we go back to the collision shape, under shape, click capsule 2D. We need to set the rotation to 90 degrees. Where is that? That's under the transform here. In the node section, we do 90 degrees, boom. And then we use the little arrows to do this. I might switch back to one of the other sprites. I guess they're all kind of different sizes, so I don't know if there's one. We'll go with the walk one. So with that selected, I'm going to just select on the collision shape. We can use the little handles or whatever they call them to make the capsule size whatever we need, which that's not perfect, but that's pretty close. Cool. And save the scene, something we have not done in a while. So good recommendation, tutorial. So we're going to add a script to the mob. once again, to do that, you just click on the mob object up here at the top right, attach a new script. We're just gonna call it mob create. Now we're back to the scripts page, which adds this extends rigid body 2D at the top for us. And then we need to go ahead and look at the rest of the script. So in the ready section, we're going to play the animation and randomly choose one of the 3 animation types. I was just straight up reading this part. So here's the function we're adding to ready. So first we're choosing the mob types, which for that we get the animator sprite and the sprite frames. And then we run this function called get animated sprite names, which just, as you can see here, this returns an array containing all animation names. So it looks something like this: walk, swim, fly. Then this next part, we're playing the animation, but which animation are we playing? So we're grabbing that mob's type array, and with arrays, you access them with square brackets to access a certain index of that array. If you're not familiar, and arrays are indexed starting from 0. So walk is 0, swim is 1, and fly is 2. And what we're doing is using this randi function. Randy, is this an Austin Powers function? Randy, baby. No, it stands for random integer. At least I assume so. And then we're using this %sign and mob types dot size. So what exactly is this all doing? And this kind of explains it here. So we basically just need to pick a random number between 0 and 2 to select one of these names from the list. So we do random I, %sign n selects a random integer between 0 and n minus 1. So the size of the array is going to be 3. So this selects an integer between 0 and 2, which is what you want. So yeah, let's go ahead, and I'm just going to copy that in since I've already talked about it. This is going right into the ready function. Boom. Simple enough. And we're moving right along. So the last piece to make the mob delete is to make the mob delete themselves whenever they leave the scene. So connect the screen exited signal of the visible on-screen notifier to the mob. And then we're adding this little function just called queue_free, which doesn't really explain what it does, but essentially that's how you remove something from the scene. Or I guess from the queue. Like I said, I'm still pretty new to Godot, so I don't know the intricacies of all the functions and whatnot, but it seems like that's just the way you remove a mob on the once it's off the screen, I guess. So we're gonna save that. We're gonna click on mob, go back to our node, and we are actually, sorry, I misspoke. We click on the visible on-screen notifier, and then on that we have the one it was looking for, the screen exited. Double click on that, click connect, boom. The visible on-screen notifier 2D screen exited. Quite the long function, but you don't really need to worry about the name. Just paste in queue_free, and that completes the mob scene. With the player and enemies ready, in the next part, we'll bring them together in a new scene. We'll make the enemies spawn randomly around the game board and move forward, turning our project into a playable game. So we're getting close. We're on the last 3 chapters. The main game scene, it's got a lot of stuff coming up, but not too much. Then we have the heads-up display, and then the finishing touches, which finishing up shouldn't take too long. We're doing pretty good on time. I was hoping to get through this a little bit quicker, but this is a decently long tutorial. I don't know how long the 3D tutorial is in comparison. Looks a little bit longer, and like I said, that's going to take me longer since I haven't done that. So yeah, we're probably going to go over the 3-hour mark today, but that's okay. You know what? I'll live. So the main game scene. It's time to bring everything together to make a playable scene. So we have to create a new scene and add a node named main. So there's a little explanation here. The reason we are using a node instead of a node 2D is because this node will be a container for handling game logic. It does not require 2D functionality itself. And then there's this instance button up here. and you can click that and select your player TSCN, or your player scene. And that will add an instance of it. So let's go ahead and let's just do that. So we're gonna go up to scene, new scene, and just click other node. I think we just do node, right? It's right at the top. We just click node. Are we gonna be naming this something? Probably just main, right? So is that what okay, that's what they named the node too. But I just want to make sure that's what we're naming the scene as well, because I like saving the scenes just right off the rip. I don't like dilly-dallying with that. Let's just go to the 2D just to see what we see. So now it mentioned we want to click the instance button up here. This pops up all of our scenes and players already selected, so we just click open. As you can see, it adds that down here as an instance of the player scene. So now we need to add the following as children of the main node and name them as shown. So we're going to be creating a timer called mob timer. We're going to be creating another timer, score timer, another timer, start timer, and then finally something called a marker 2D, which will be named start position. The mob timer is to control how often mobs spawn. Score timer is to increment the score every second. Start timer is to give a bit of a delay before starting. And then start position is to indicate the player's start position. Who would have guessed? So it has some default values, but let's go ahead and create all of those first. Name them properly, and then we'll go through and setting up the values. So make sure you're clicked on main, not player. And we're going to add some nodes. So specifically, let's just do all the timers first. So first timer, and we're calling this one mob timer. Then click on the main again, add second timer, click on the name. This one is score timer. Main again, add third timer. Click on the name again, and the last one will be start timer. And there's our 3 timers, and then finally, last thing we need to add is a marker 2D. Simple enough, and let's make sure we have that named start position. Whoops, position. Great. So there, if you click on a timer and we go to the inspector over here, see there's a couple of values here. Specifically, there's one called wait time, and that's what we're going to be setting the default values of for some of these. So we're setting mob timer to be half a second, score timer to be 1 second, and start timer to be 2 seconds. So mob timer is, we'll just type it in, 0.5. The score timer is set to 1, which is set to by default. And then start timer, we are bumping up to 2 seconds. Cool. Timers have been initialized. So additionally, we need to set the one-shot property of start timer to on, and the position of the start position to 240 by 450. So let's go ahead and do that. So we have to click on the start timer first, the one shot, click that to on. As you can see here, property of one shot, because I wasn't even sure what this does. If true, the timer will stop when reaching 0. If false, it will restart. Pretty simple. And then we need to click on start position. It says we need to set the position to 240 by 450. Where's position? It's under transform. So click on that, 240 by 450. And there that is. Hello there, try something dev. I appreciate the raid. Welcome in, raiders. We're learning a bit of Godot today. This is my first stream ever, so I'm sorry if Nightbot's also yelling at you already, but I appreciate the raid, appreciate the follow. Welcome on in. We are going through the Godot 2D tutorial. We're almost done with it. We're got like a couple more steps left, and then we're going to be going through the 3D tutorial. So yeah, welcome on in. Hope you're doing well. what were you all doing over at on your stream there? Try something. Once again, I really appreciate the raid and all the follows. Welcome on in. Very exciting. It's my first time streaming software on Twitch, and it makes me so happy that there's a whole like section for it now, a whole category, and that it seems to be doing pretty good. So Minecraft plugin that lets you help streamers play Minecraft from Twitch chat. That sounds awesome. Minecraft plugins and mods are something I definitely want to get into at some point because I have zero experience with it, but that sounds pretty cool. IDK what Godot is, but I'm excited to learn by watching. Godot is just a game engine that you can create 2D and 3D games. It's like, you know, Unity, Game Maker. It's one of those, but it's one I'm still very new with. I am pretty much a complete beginner, so that's why I'm going through this to learn myself and also help teach people about it. What am I building today? We're building a 2D game and a 3D game with going through this little Godot docs document. It's compatible with those 2D and 3D. Yes. That's what we're going to be doing. We are almost done with the 2D game. And then, well, not almost done, like 75% of the way done. And then we're going to hop to making a 3D game with it also. So you can see, I can click back at the beginning. Here's a little preview that they have on the site of like the game. It's a very simple, just like dodging the enemies is what this 2D game is. And then the 3D game is just like a 3D version of that, which is pretty sweet, I think. So yeah. Yeah, once again, thank you for the raid. Welcome in, raiders. I appreciate all the follows and all that great stuff. I should mention also, I am streaming both on YouTube and Twitch. So this is very new to me, but I am streaming on both platforms. So if you're active on YouTube, you want to give me a follow on YouTube, I'm Software with Thomas on YouTube as well. And since I'm new to Twitch, my streams are going to be disappearing after 7 days, but on YouTube, they'll just live there. So feel free to drop me a subscription over there as well. I would definitely appreciate it. But yeah, we already, we're on the main scene. So we've already created the player, we've coded the player, we've created the enemy. So right now we're kind of creating the main scene to bring everything together. Godot is dope. I hope it gets the Unity style gamification document after a while. Yeah, personally, I don't have much game dev experience, but I do have some experience with Unity. I've worked on it in the past, but because of some recent Unity decisions, I've been wanting to learn something other than Unity. So I've heard many good things about Godot, so that's what we're doing this today. And in the future, another one I really want to learn is Game Maker, because I've heard good things about that as well. And I am also like completely new to it, but yeah, so far Godot seems pretty awesome. There's definitely some weird like things I have to think differently coming from someone who did some Unity development, but a lot of it is like very much simplified, which I like. So yeah, that's what's going on. So let's get back to this. We'll keep cracking away at this. So we've just created some timers and the start position. So now we need to get into spawning the mobs, which I guess I can also make this a little bit bigger. That might be helpful. I don't know how hard it is to see. So the main node that we created for like the scene will be what's spawning the mobs, and we want them to appear in random locations at the edge of the screen. So what we're going to do is add a 2D path node called mob path as a child of main. And then when you select the path, you will see new buttons at the top of the editor like this. So what we're gonna do is select the middle one, and that's the add point, and we can draw paths by clicking the points on the corner as shown. To have the point snap to the grid, you can use grid snap and use smart snap. They're both selected. These are those options. And as it mentions, draw them in clockwise order, or your mobs will be spawning outwards instead of inward. And then after you click point 4, you click the close curve button, and that will complete your little path, which is pretty cool, and have a little area on the outside of the screen for your mobs to spawn. That's the complete path. So let's go ahead and do that. Should be pretty easy, right? Famous last words. I'm also going to recenter the screen, zoom in a bit, and let's also just save this. I like saving often. I don't like having to maybe, lose all my progress. I haven't had any crashing yet, which is good, but so we're adding a new new node to the main node, and we're calling it, what was it, mob path? Mob path. And then we click the middle button, which is the add point. We can do the snap to grid and that. And now we need to go find the game screen outline, which this was, when I first did this, it's kind of hard to see. I think the grid makes it hard to see. Yeah, so we click there, bottom, the bottom, and then we click complete curve. And that's it. Mob path created. And it's as simple as that. Seems very easy. What's the catch? So, that's what I've been working with Godot. A lot of things are like, especially coming from Unity, which I was not an expert by any means in Unity. A lot of things are a lot easier. I've been really liking Godot so far. But once again, I am very much a noob. I have only literally used it for the first time last week. So, and that was just going through this 2D tutorial. But so far, has a lot of nice things about it. I'm hoping it gets more traction, gets more attention, because I think it seems pretty great. But yeah, so now we have this path defined. We can do something called add a path follow 2D node as the child of mob path and name it mob spawn location. This node will automatically rotate and follow the path as it moves, so we can use it to select a random position and direction along the path, which we just click on mob path, add node. And it's just this follow path, right? I have, yes, the path follow 2D, add that, and then we name it mob spawn location. If only I could type. I got a new keyboard last week, so I'm still adjusting to it. So I'm gonna be making a lot of like typos and whatnot along the way. And so our scene should look something like this picture, which mine looks exactly like that, so that's a good sign. I didn't really mess anything up. So now we're on to the main script. So we're going to add a script to the main, which you just click on the main node, add script, create, and we're in it. At the top of the script, we're going to use export variable mob scene. So once again, at export just makes it a variable that you can change in the inspector, and then we're setting it to packed scene. And then we're also adding this score variable to keep track of the score. So let's go ahead and just add that in right here at the top. One of the reasons Godot is a bit easier is that it doesn't have a huge shader part in it. Rather, it wants you to do shaders in Blender and then import them from that. Oh, okay. That was, yeah, I could see that being the case. Because, yeah, I don't know. It's just one less thing to worry about, but obviously then it's a little bit more limited. But, I mean, it seems like some of the stuff you can do with Blender, with shaders and just creating, like, models is crazy. Like, Blender is something that I will personally never learn, but the stuff people make with it is outstanding. I just feel like that's something I could really never do. Or I maybe could if I put the time into it, but, you know, I'm going to learn Godot instead, and someone else can learn Blender, and then we'll make some cool stuff together. But so yeah, we're just adding this mob scene variable, and then we're adding the score variable. So if we click on our, the main node, we will now see mob scene over here under the script variables. So then we can assign it the value by just clicking here, click load, and click the mob scene right there. Simple as that. Now the mob scene is linked. One thing that's weird, like, especially because I'm coming from Unity, is like the idea that like everything is kind of like a scene. Like, that's kind of weird to me to get my head wrapped around, but that's just how we do it in Godot land, I guess. But it seems to work pretty well, but it's kind of weird to kind of wrap my head around that you're just like adding a mob scene, and that's like kind of like the object, but it's not an object, it's a scene. And so now we need to select the instance of the player scene under the main, which we added earlier, and access the node dock on the sidebar. Boom. And we have to make sure to have the signals tab selected in the node dock. We do. So we see a list of signals for the player node. Find and click the hit signal that we created earlier. So signals are custom things that you can add. We added this one earlier for player. So we just double click that. So open a signal dialog, and we want to make a new function called game over. So we just type in the function name game over, and this will run whenever this signal fires off. And then we just click connect, and boom, it adds it in here. And it has the little green arrow showing it's hooked up to a signal, and you can see it over here. It's hooked up to game over. Pretty sweet. I've seen people use Blender as a video editor, really. I did not know that was a thing. Rather than think of it as a container or a link. That's definitely, yeah, that makes sense. Because like in Unity, they have like prefabs. That's kind of like my equivalent in my head. It's kind of like a prefab. Yeah, I like the idea of like a container. I feel like that's a better way to phrase it, better way to think about it. Yeah, like I said, still new to this, still learning the ropes, but very much liking it. So now we have this game over function that's going to run whenever the hit signal is emitted from the player, and we can handle it now in our main script, which is kind of cool. So now, go back to the tutorial, is jumping ahead a little bit, as this is all the stuff I just went through. We're going to add the following code to the new function, as well as another function called new game that will set everything up for our new game. So game over is going to do two things. It's just going to stop the score timer and stop the mob timer. Pretty simple. So let's go ahead and just paste that in right here. Just stops both of those timers. And then the new game does a few things. It sets the score variable we created to 0. The player start will be the start position, and then we start the start timer. How many times can I say start in one sentence? And I guess this is a new function we're creating, so I'm just going to copy the whole thing because I'm too lazy to type. And I've already kind of talked about it, so there. I personally need to have stuff explained in terms of .NET or Docker YAMLs. Man, Docker. I've used Docker in the past, but I've had some not bad experiences with it, but just like a lot of headaches when I used it a while back. But I respect Docker for what it is. It's just an awesome thing, and I'm glad we have it. But sometimes it could be a pain. So now what we need to do is connect the timeout signal of each of the timer nodes. So start, score, and mob timer to the main script. Start timer will start the other two timers, and score timer will increment the score by 1 second. So I guess I forgot that I don't have this pulled up. My bad. This is what I was just reading. And so we're going to add these two scripts, the on score timer and on start timer, which we do those by clicking on the score timer, going over here. Right there's the timeout function that we just double click connect, and boom. So now here, which this one is the on score timer. So we're just adding +1 to our score. Go to the start timer, click the timeout function, connect. Now it's connected to our main script. And we are just adding in these two bits of code to start the mob timer and start the score timer. So the start timer just gives a bit of a delay at the beginning once you click start before stuff starts up. What is this song? I don't know if I'm really a fan of it. Okay, let's just go like here. There we go. Hopefully the music's not too loud, by the way. Like I said, today is my first stream, so technical issues haven't been too bad. I think I got audio levels pretty decently, but let me know if anything's too loud, too quiet, or anything of the sorts. Docker isn't a thing about now. It's all Kubernetes. Oh yeah, Kubernetes. I have a friend that works with Kubernetes. He loves it, but also that's what he does for his job, so he's kind of a sucker for it. But yeah, Kubernetes seems awesome. But I've not even touched that. I've messed with Docker a bit, but Kubernetes is never had a use for it, I guess, or a need to use it. So that's the main reason I haven't messed with it much. Okay, we got these two timer functions set up, but we got to do a third one. This one's going to be the longer one. As you can see here, there's a lot of stuff going on. So the on mob timer timeout will create a mob instance. So it picks a random starting location along the path 2D that we created around the border, and it will set the mob in motion. The path follow 2D node will automatically rotate as it follows the path. So we will use that to select the mob's direction as well as its position. When we spawn the mob, we'll pick a random value between 150 and 250 for for how fast the mob will move, because it would be boring if they all moved the same speed. Note that we add a new instance must be added using the add child functions. There's a lot of stuff going on, but luckily they have it all labeled very nicely. So let's go through it line by line. I'll quickly talk about it, paste it in, and I guess we'll be able to test the scene here in a second. See how it all is coming together so far, but we're almost there. We're just got to finish this, add the heads up display, and then a couple finishing touches, which are optional, but we're going to go through them anyway. So first we got to create a new instance of the mob scene, which is just we have the mob scene variable. We're just calling instantiate on it. And we're choosing a random location along path 2D. So location is just the mob path divided by / mob spawn location. And then the location is just, we take the progress ratio and do a random float value to get kind of a random location. The direction is we take the mob spawn location and we take the rotation of it and we add pi divided by 2. And that sets the direction perpendicular to the path direction. And this goes into a little bit more about pi at the bottom. We set its position by taking the mob spawn location and just taking the position. We add some randomness to the direction. So for the direction, which we create up here, we add a random float value between pi divided by 4 and pi over 4. And then mob.rotation just equals direction. And then finally, we set the velocity. So velocity is a vector 2, and we do a random float range between 150 and 250. And then that's just the one value, and then the other value for the vector is just 0. So finally, we just set the linear velocity to this .rotated, velocity.rotated with the direction we created, and then finally we bring it all together by adding child of mob. That's a lot of code. It's fine if you don't fully understand all of it. I'll be honest, some of it is definitely confusing. I'll read this important because it's important. Why pi? Well, in functions requiring angles, Godot uses radians, not degrees. So pi represents a half turn in radians, about 3.1415. There's also tau, which equals 2 times pi. If you're more comfortable with working with degrees, you need to use the degree to radians and radians to degree functions to convert between the two. So we're just going to copy all this and add it in because I no reason to see me type that all slow here. So we go to the mob timer, the timeout signal, double click, click connect, adds that to our main function. Boom. And I guess my naming of mob timer is a little weird, but that's fine. It knows what I mean. And so we add that all in and we're almost ready to test, it looks like, which I'm very curious to see. I hope this goes well. So let's test the scene to make sure everything's working. Add this new game call to ready. So we're just calling new game. Let's also assign main as our main scene, the one that automatically runs when the game launches. Click play and select main scene when prompted. If you already set another scene as the main scene, you can right click on main in the file and click set as main scene. So all we gotta do is add this under ready. And we're gonna be able to see how this is looking so far, which hopefully doesn't like crash. That'd be awkward. So I've been following this tutorial pretty good, I think. Oops, I wanted to save it. And then over here in the file structure, I'm going to find the main scene we've created, right click, and set as main scene, wherever the heck that is. There it is. So that's the main scene now. And now we click run and hope that stuff happens. Oh no, it did crash. No. Okay, I think I need to, it's because my mob timer function is just named weird. I had a capital I, so I think that's the case. I thought it wouldn't matter, but apparently it does. I hope that's the only issue and I don't have to troubleshoot right now. And look at that, we got mob spawning and, well, I already died. I'm not doing too good at my game. Let's retry that. I was trying to make the screen big before stuff starts happening. Okay, we can move around, the animation's good, and I died again. I suck at my own game. That's okay though. Seems to be working good so far. Yeah, a little bug there, but figured it out pretty quick. And we're moving right along. So what's our game lacking? Some user interface. So in the next section, we will add a title screen and display the player's current score. We're on the second last chapter. Second last chapter. So heads up display is what HUD stands for, as it mentions here. So the final piece is our UI that displays stuff like a game over message and a restart button and the score. So we're going to create a new scene, click other node, and add a canvas layer. Name it HUD. HUD stands for heads up display. So let's go ahead and do that before reading too far along. So we go to scene at the top, which is kind of covered by my UI. Click new scene, other node, type in canvas layer. And that's down here. Click create. We're going to name it HUD. And we're looking good. So then what is next? I need to stop. I keep switching between the wrong things. There we go. My bad. Sorry for the back and forth. The canvas layer node allows us to draw UI elements on a layer above the rest of the game, so that the information isn't covered up by any game elements like mobs or players. So the HUD needs to display the following info: score, which is changed by the score timer, a message such as game over or get ready, and then a start button to begin the game. So a basic node for UI elements is control. So to create our UI, we need two types of control nodes, the label and the button. So we're going to create the following children for the HUD node. We're going to add a label named score label, label named message, button named start button, and timer named message timer. So let's quickly go through and add all of those in. That should only take a second to do. I'm going to also save this because I'm getting paranoid about not having it saved. So go in here, new node, and we're first adding a label. Boom, calling this the score label. Let me make sure I'm actually typing stuff right, because clearly that matters. Next, we add another label, calling this message. Then a third label. No, not a third label, my bad. Undo that. I was getting ahead of myself. Too many labels. No, we got our two labels. We just need a button now that I can't type correctly. There we go, button. This will be the start button. Pretty simple, but you know, it's got to be done. Nice typed start button. These buttons are going to be the cause of all of my bugs, I swear. And then one final thing, we're adding a timer. And this is going to be called message timer. Sure, I'm really typing stuff right. I don't want to get any more mistakes, no more bugs. Okay, so what next? So we're going to click on the score label and type a number into the text field in the inspector. So in the inspector over here, text field, I'm just gonna type 0. Boom, super easy. The default font for control nodes is small and doesn't scale well. There's a font included in the game assets called Zonolium Regular. To use this font, do the following. So we got to go to Theme, Overrides, Fonts, and Load. So where the heck's all of that? So we go to Theme, Overrides down here. Boom. Fonts. Empty. Load. Fonts. Click the font. And we're ready to roll. The font size is too small, so we need to also increase that. So Theme, Overrides, Font sizes. 1 pixel, we want 64 pixels is what we're going for. Repeat the changes for the message and the start button. So let's go do the same. Message, theme overrides, font. I guess we just do load again. I don't know if, I guess we have to reload it every time. Font size, 64. And then finally, start button. Theme overrides, fonts, load, fonts, font size, 64. And now our fonts are all good. So this is what we just did, all that stuff. So anchors, we're gonna get a little bit into anchoring UI things, which is what I remember. Like I said, I'm pretty new to all game development. When I did stuff in Unity, I remember making UIs was my least favorite part because anchoring and scaling was always such a pain. But it's actually it's pretty easy in Godot. So anchors, so control nodes have position and sizes, but they also have anchors. Anchors define the origin, aka the reference point for the edge of the node. So we want to arrange the node as shown below. You can drag the nodes or place them manually, or for more precise placement, use the anchor presets. So we're going to end up with something like this. So for the score label, we want the text to be 0, set the horizontal alignment and vertical alignment to center, and choose the anchor preset center top. And then message, we're doing dodge the creeps for the text, horizontal and vertical alignment to center, auto wrap mode to word, layout and transform, we're setting the size to 480 to fill the entire width of the screen, and choose the anchor preset center. And then start button, text start, setting the transform size X to 200 and Y to 100, make it a bit more button sized. The anchor preset will be center bottom, and then the layout for the position of Y will make it 580. So that's that. And then we're gonna go through and do all that real fast. Shouldn't take too long. So we're gonna start with the score label. That's the first thing that needs done. We're gonna hop back to the 2D scene, center it, zoom in a bit so we can actually see, see our little, it's kind of hard to see the outline of the screen. It's very, like the blue outline there. Maybe it's more visible for you. Score label is already set to 0. So over here, horizontal alignment, center, vertical alignment, center. And then anchor preset is the center top. So we go up to here, anchor preset. That's not the right place, is it? Did I click the wrong spot? Oh, I did. Yeah, it's this one. I was like, wait, start panicking here. Center top. Boom. First one done. Message, we are just adding dodge the creeps as the text here. And then horizontal alignment and vertical alignment both being center. Then auto wrap mode to word. Great. Under the control down here and under layout, under transform, we got to go a couple layers deep to get to here, but we made it. First, we're going to set the size of X to 480 to take up the entire screen width. Great. And then we're going to do the anchor preset up here of center. Done. Then start button. Add the text start. Easy. Under the control, layout, transform, changing a whole bunch of stuff. So we're going to set X to 200 and Y to 100 for the size. So X 200, Y 100. So we got an actual start looking button. And now we just need to set the anchor preset to center bottom, which is this one, right? Yeah, that one. It's like, why didn't it go? I guess I didn't click it fully. And then we're going to set the position to 580. So the Y position will be 580. Not that. That is not the number we want. There we go. And that looks like what the other screen shows. So we got all of our UI in place. I'm going to save, and we're moving right along. So on the message timer, we want to set the wait time over here to 2 seconds, and the one shot property to on, which one shot just means that the timer will stop when reaching 0. Now we need to add a script to the HUD, which we do by clicking on HUD, click script, and create. It extends the canvas layer. That's good. And we want to add a signal to the top. So just did all of that, and we're right here. So we're just adding a new signal called start game. That this will notify the main node that the button has been pressed. So we'll just add that in at the very top here. And we now want to display a message temporarily, such as get ready. So what we're going to do is add the following code here for a function called show text that takes any text parameter. We set message text to that text. We then show the message, and then we start the message timer. So we also need a process that shows what happened when the player loses. We'll get to that. Let me add these in maybe down here. Show message function, boom. We then also need to process what happens when the player loses. So this code below will show game over for 2 seconds, then return to the title screen, and after a brief pause, show the start timer. So it runs that show message function we just made with the game over text. Then it will wait until the message timeout is done, which should be 2 seconds, because that's what we just set it as. Then once that 2 seconds is up, it'll change the text to dodge the creeps. It will show the message, and then it will create a one-shot timer and wait for it to finish with a timeout of 1 second. So this essentially just waits 1 second, and then it will show the start button. And that's the show game over function. So let me add that down. We'll add it right there. Sure, at the bottom. Great. Yeah, so this function is called when the player loses. It will show game over for 2 seconds, return to the screen, brief pause, show the start timer. Little note here, so when you need to pause for a brief time, an alternative to using the timer node is to use Scene Tree's create timer function. This could be helpful to add delays such as in the code above, where we want to wait for some time before showing the start button. So we're going to add this code called update score that takes in a score variable and essentially just sets our score label.text value to a string of whatever the score is. So we'll throw this into our main script here. Well, it's not the HUD script, I guess. The main script is something else. And that's pretty straightforward, just adding a little bit of a score. So now we need to connect the pressed signal of the start button and the timeout signal of the message timer. And we'll add the following code to those functions once that's created. So let's go ahead and create those. So we click was the pressed button of this, the pressed signal of the start button. So we click the start button, over to node, find the pressed signal, double click that, add, and boom, that adds the function here, which I love this whole like signal part of Godot. It's a really cool aspect of it that you just double click that and then it links it to the script. It's pretty sweet. So we do that, and the other one is the timeout for the message timer. So we do that, add the timeout function, connect. It's so simple. I love it. So when the start button is pressed, we hide the start button and then we emit the start game signal, which is what we created up here. So on start button pressed, we will add in those 2 simple lines. Great. And then once the message timer is done, all we do is just hide the message. Pretty straightforward. Boom. So now we need to connect the HUD to main. So now that we're done creating the HUD scene, go back to the main. We're going to instance the HUD scene in main like we did with the player scene. The scene tree should look something like this. So make sure you don't miss anything. I will make sure I don't miss anything, but hopefully I haven't. So we save this. We go back to the main scene and we click on main. We click on the little chain thing to instance a child scene. We click on HUD. We click on open. And I'm double checking my stuff matches up with theirs, and it looks like we're good, which is great. So now we need to connect the HUD functionality to our main script. This requires a few additions to the main scene. So in the node tab, we are going to connect the HUD's start game signal to the new game function of the main node by clicking the pick button in the connect signal window, selecting the new game method, or you just type new game, and the receiving method in the window. And we verify the green connection icon appears next to the function new game in the script. So let's go ahead and do all that, because that seemed like a lot, but it's not too bad. So we click on HUD, boom, got this start game signal. We click on that, make sure I'm not doing anything right. Then we click the little pick thing there, brings up all the functions in our main script. We click on new game, click OK, click connect. We wait a second, and now you see here, there's the little green icon that we're supposed to see next to new game, and we can see that start game from the HUD links to the new game function in our main script. Super cool. I love that. And I think that's all we have to do there. So now in the new game function, we also want to update the score display and show get ready as the message. So we do that by running our update score function with the score that we have just stored here in at the top of our main. And then we also are going to just show message of get ready. So let's add that to our new game function. And make sure it's properly indented, or else we're going to get yelled at by the editor. And then we're getting close here. We're in the end game. I mean, there's only a few more things to do, and then we'll be able to test it and add our final touches. So in the game over function, we need to call the corresponding HUD function, show game over, that's all we have to do. Is just add that function call into game over. Boom. Done. Back. And then finally, we add this to the on score timer timeout to keep track, keep the display in sync with the changing score. So yeah, we just update the score whenever that runs. So on score timer timeout, the score gets incremented by 1, and then we update the HUD with the update score function that we just created, just like that. Remember to remove the call to new game from ready if you haven't done so already. Otherwise, your game will start automatically. Good call. I definitely still have that there. Glad I had that reminder. Now you're ready to play. Click play the project button. You'll be asked to select a main scene. Make sure to choose main. And let's see how our game is looking currently. Look at that. So we got a nice little main screen. It says dodge the creeps, shows our score. We got a start button. We click start. It says get ready. Gives us a second, and then enemies start spawning in. And you can see the score is incrementing the longer we stay alive. Okay, I'm panicking here. And I got a score of 7. Not bad. 7 seconds is what I survived. And then you see after a second, main menu comes back up, and we can click start again. Our score will reset, get ready, and we could just repeat. I'll just die on purpose here. That was totally on purpose. And cool, we got a working game. We're real close. There's a few more things we got to do though. The last part of this section is removing the old creeps, which is not too hard to do. So if you play until game over and then start a new game right away, the creeps from the previous game may still be on the screen. So it'd be better if they disappeared at the start of a new game. We just need a way to tell all mobs to remove themselves. We could do this with the group feature. So in the mob scene, you can select the root node, click the node tab, which is like where the signals are, but there's another button called groups. And then you can type in a group name and click add. So we're gonna just add in a new group called mobs. And then we can add this following line into the new game function that just says, we call group of mobs and we just call the queue free function, which just essentially removes them. So let's do that. So we go to the mob scene here, click on mob over here in the node tab. Instead of signals, we click up here on groups and we just add mobs. I'm pretty sure that's plural, right? I don't want to, that probably doesn't matter too much, but yeah, we'll add mobs there. We save that and then go back to main, and then our new game function, we just add in this little function here. So this gets the tree of all the different scenes, I guess. And we call this with the group, we call a function on the group of mobs, and the function is queue free, which should just remove them. Game's mostly done at this point, and the next and last part, we'll polish it a bit by adding a background looping music and adding some keyboard shortcuts. Let's see where we're at again. I'm gonna try to see if that is working now with it removing them. So I'll have to just try to end a game and start another one up really quick. Okay, I was trying to move with WASD. I can't even test it because the mobs are moving off the screen like at the perfect time. Because there's a bit of a delay, so I just can't even really test if it's working, but I think it is. I mean, it should be. Let's try this one more time. I need to die like close to the edge of the screen, so then I guess that wouldn't really matter, would it? The timer's just too long, so I can't even test if that last part works. Well, let's just assume it does. Because I've been following this tutorial pretty close. And we're on to the last step, finishing up. Completed functionality for the game. Below are some remaining steps to add a bit more juice to improve the game experience. So first is the background. The default gray is not very appealing. Let's choose a different color. One way to do that is to use the color rect node. You make it the first node under main, so it'll be drawn behind other nodes. Color rect only has one property, which is color. Choose a color you like, select the layout, anchor presets, full rect, either in the toolbar or at the top of the nav, the viewport, or the inspector. You can choose to add a background image if you have one using a texture rect. So let's go ahead and do that real fast. So background, go to our main scene, click add node, and it was a color rect. Cool. And it said to make it the first node under main, so we need to make sure to do that, so just drag it up there. And if we go to the inspector, there's only one thing here, and that's the color. And let's just make it like a nice blue, maybe. Something like that, sure. We can just save that and see if that replaces our boring gray background. Oh no, it didn't. What happened? I didn't set the transform like it said. So we got to go to layout, anchor presets, and then we have to click the full rect button. There we go. That's what happens when you skip a step. And look at that. Now we got a nice blue background. Better than the boring gray. And I lost because I was pressing the wrong keys. But whatever. Sound effects is what's next. And then the last one's keyboard shortcuts, which we'll probably just skip. But maybe since we're doing all of this, we might as well do that as well. But let's do sound effects. So sounds and music can be the single most effective way to appeal to the game experience. In the game's art folder, you have two sounds: house and forest loop for background music, and game over.wav. For when the player loses. So we add two audio stream nodes to the main as children. Name one of them music, the other death sound. So let's go ahead and do that. Main, add, and that was audio stream. Was it just audio stream player? So not 2D. Make sure I'm doing the right one there. And we click on main again. Another audio stream player. Okay. First one will be music. If I could type correctly, that would be great. And the next one is death sound. Cool. So on each one, let's click on music. We click the stream area over here and click load to load the corresponding file. So this is the music. So we just go into art, house in the forest, I guess it's the name of the background music they have for this. We click load, art, game over.wav. Great. All audio is automatically imported with the loop setting disabled. If you want the music to loop seamlessly, gotta do a thing. So you gotta click on the stream file arrow, click make unique. That's first step. Then you click on the stream file that opens up this little box, and you click on loop on. And that's that. So, which I'm just run through like all this stuff here. So now we need to actually play the music. So we just add music.play to the new game, and then music.stop to the game over. And then we add death sound play in the game over function. So game over, we just add the music stop and the death sound play at the end. Simple enough, simple enough. And then new game, music, play. Just add that at the bottom, save it, and let's give this a test run. So there should be nothing at the beginning. We click start. Oh my gosh, that's loud. I'm sorry if that's loud for you too. There's the game over, and then you notice the music stops. You click start, and then the loud music starts again. I'm sorry if that's really loud. That's pretty loud for me. And it looks like you could easily change the volume right here. Which maybe I will, just because we'll be probably testing this some more. Let's go like, I don't know. Give me that slider back. Get out of the box. I want the slider. There we go. -27. How's that? Is that a little bit better? Okay, that is a little bit better. It's kind of quiet now, but that's... The game over is kind of loud. But hey, we got music. We got sound. Love to see it. We are on the final section of this 2D tutorial, which is keyboard shortcuts. Since this game is played with keyboard controls, it should be convenient to, if we could also start the game by pressing a key on the keyboard. I would agree with that. We can do this with the shortcut property of the button node. So in the previous lesson, we created the 4 input actions for the character. We will create a similar input action to map to the start button. So we're gonna go back to the project settings and the input map tab. In the same way we created movement input actions, we will create a new input called start game and add a key mapping for the enter key. Let's go ahead and do that. Should be pretty easy, right? Famous last words. Now this is simple. Settings, input map, we're already there. Add a new action called start game. We click the add button over here. We click enter, and just like that, we're good. Now would be a good time to add controller support if you have one available. I don't, so sorry, we're not doing that. In the HUD scene, okay, so I think we're done with this. Close out of that. So in the HUD scene, what are we doing? We select, I guess I can pull this back up. So in the HUD scene, we select the start button, find its shortcut property, create a new shortcut resource by clicking within the box, open the events array, add a new array element to it by clicking array, input event, size 0. We create a new input event, call it start game. And now when the start game button appears, you can either click it or press enter. Okay, that was kind of a lot, but it should be pretty easy, right? So we click on the start button. We can close out of this stuff because we don't really need the layout at the moment. We need to find the shortcut property right here, boom, under base button. And then we create a new shortcut resource by clicking within the box to open the event array. So we do that. We click the events there. We have a size of 0. And then we click add element. Okay. And then I guess I could probably expand this because it's kind of small, getting cut off there. We click on the empty, and then we're adding a new input event action, which is down here at the bottom. And name it start game. How do I name it? So we got to click it again. And then the action up here, we just call start game. I think we leave all the other stuff as is, and I guess that's it. Let's see if that actually works. It'd be kind of crazy if it does. I mean, I don't know why it wouldn't, but I mean, maybe I made a typo. So I'm just gonna not click it. I'm just gonna click enter, and it starts. And that's it. That's the 2D tutorial for Dodge the Creeps in Godot. Took a bit longer than I anticipated, but that's okay. That's totally fine. Yeah, that's the end of the tutorial. So you get to make a player-controlled character, enemies that spawn randomly around the board, count the score, implement a game over and replay, user interface, sounds, and more. Congratulations, but there's still much to learn. But you can take a moment to appreciate what you achieved. When you're ready, you can move on to your first 3D game turn to create a complete 3D game from scratch in Godot, which is what we're going to be doing next. I'm going to take a quick break first. Y'all feel free to take a quick break at home, stretch, grab some water, hit the restroom, whatever. And I will be back here in like 3 minutes, 5 minutes, something like that. So I'll see you in a bit. All right, let's hop back into this. Wait for my scene change to go through, and hello everybody, and welcome back to Learning Godot, where we just got done creating that 2D game. Definitely took a little bit longer than I anticipated, but hey, we did it. Didn't really have any bugs along the way, which is great. And now we're gonna get into creating the 3D game that they have here for their little demo. So I kind of mentioned this at the top, but I'm very new to Godot. I've only started using it last week, and only thing I've done is done that 2D tutorial. So this tutorial will be new to me. 3D stuff will be new to me. It's probably gonna be a bit slower going. Probably gonna make some more mistakes along the way. But hey, it's all part of the learning process, right? And yeah. Normally I was in my head, I mean, this is my first stream, so not normally, but I was planning on just the stream being about 3 hours, but I think we're going over a little bit over today because I'd like to see how much of this 3D game we could get through. And it looks like there's a fair amount to it. I don't know how much more difficult it will be, how much more time consuming it will be, but should be fun. So yeah, let's get hopping into this. So, this game is going to be similar to the first 2D, but with a twist. You can now jump, and your goal is to squash the creeps. So, this way, you'll both recognize patterns you've learned in the previous tutorial and build upon them with new code and features. So, in this tutorial, you will learn to work with 3D coordinates with a jumping mechanic, use kinematic bodies to move 3D characters and detect when and how they collide, use physics layers and groups to detect interactions with specific entities. We'll code basic procedural gameplay by instancing monsters at regular time intervals, design a movement animation and change its speed at runtime, and also draw a user interface on a 3D game. So I hope you're all ready for that because we're about to get into it and more. It says and more. So this tutorial is for beginners who followed and completed the Getting Started tutorial series. We'll start slow with detailed instructions and shorten them as we do simpler steps. If you're an experienced programmer, yada yada, you can just look at the source code. They have that available. And they've prepared some game assets, so you could jump straight into the code. You can download them here, which I've already done so. We will first work on a basic prototype for players' movement. We will then add the monsters that will randomly spawn around the screen. After that, we'll implement the jump and squashing mechanic before refining the game with some nice animations. And we'll wrap it up with the score and retry scene. So we're gonna get started by setting up the game area. So let me switch back to Godot here. Make sure it's all saved from our last project, and I don't know, I'm just gonna close out of it, I guess. I need to like reopen it now. So we get this, here we go. Yeah, new screen. And we're going to import. And it looks like we're just importing, enter the path to the freshly created directory. Oh wait, this creates a directory? And click browse on the right hand corner. So I import. I'm gonna move this on. I don't want to like accidentally like leak something dumb. Let me just do this off screen real fast here. I mean, it's just in my download, so it's not like anything really is gonna be leakable. But you know what? I'd rather be safe than sorry. So that'll be awkward first stream, and I just like leak something. So we did that, click browse, did that, click the file, click edit and import. Looks like this was generated with Godot 3 and needs to be converted to Godot 4. You have 3 options: convert the configuration file, convert the entire project, do nothing and go back. I'm gonna go with I actually don't know. See, this is the downside of me not having done this before. I'm just gonna go convert the full project. Let's just see what happens. Let's perform a full project conversion. Yeah, let's give it a go. Let's give it a Godot and see what happens. Maybe it'll completely crash this. I don't exactly know. Did it just disappear? What happened? Did it already convert? Do I need to open it again? Okay, it looks like it converted and then just didn't tell me. I think it kind of worked. I hope that was the right answer. But hey, we got a project. Contains 2 folders, art and font, which I definitely see here. That looks good. There are 2 types. There are 2 3D models. We got player.glb and mob.glb, and some materials that belong to these models, and a music track. Cool. I guess I should pull back up the tutorial, shouldn't I? I'm just reading off my other monitor. So we're going to be setting up a playable area. So we're going to create our main scene node with a plain node as its root. In the scene doc, click add child and click plus. Click on the node, name it main. Yeah, that's all pretty standard. Then we're going to save the scene as main lowercase. It probably doesn't matter, but you know what? Can't hurt to do it the way it tells you to. So create the new node, name it main, click save, name it main. Cool. So we'll start by adding a floor that prevents the characters from falling. To create static colliders like floors, walls, ceilings, you can use static body 3D nodes. They require collision shape 3D child nodes to define the collision area. So with the main node selected, we add a static body 3D node, then a collision shape 3D node, and rename the static body to ground. And it should look something like this. So we're adding the collision to the static body. Got it. And then we're naming the static body to ground. Got it. Okay. Simple enough, surely. Surely I can't mess this up. So we got to do the static body 3D down here. Whoops. Add that. Then we click on that. And to that, we add collision shape 3D right there. And then we click on the static body and we name this ground. And now our thing looks like their thing. And it says, you know, a warning sign next to the collision shape appears because we haven't defined its shape. If you click on the icon, a pop-up will give you more info. So to create a shape, we click on the collision. We head to the inspector, click empty. Next to the shape property, we're going to create a box shape 3D. So we click on the shape and box shape 3D. Boom, look at that, we got a box. Oh man, this is basically a game already. We're pretty much done. We got a box. It's awesome. All right, the box shape is perfect for flat grounds, like flat grounds and walls. Its thickness makes it reliable to block even fast moving objects. Cool. Where are we at? Okay, right here. So a box's wireframe appears in the viewport with 3 orange dots. You can click and drag these to edit the shape extent interactively. We can also precisely set the size in the inspector. Click on the box 3D to expand the resource. Set its size to 60 on the X, 2 on the Y, and 60 on the Z. Okay, let's do that real fast. So we click on the box shape 3D. And I guess I assume they meant the collision. Because we haven't added a box shape 3D, right? That's just the collision. I hope that's what they mean. I think that's what they mean. And we're setting its size. No, we gotta click on the, okay. Yeah, see, this is newbie mistake. We actually do have to click on the box shape. Click that to 60. Oh man. Click the 2 for Y for the thickness, and then 60 for the Z. Cool. As we can see here, we got a big ground going on. Sweet. Okay. So collision shapes are invisible. We need to add a visual floor to go along with it. So we select the ground node and add a mesh instance 3D as its child. So let's go ahead and do that. Mesh shape mesh instance 3D. Yeah. That's the one. That's the one we want. And we're on our way. So now in the inspector, sorry, I keep not pulling up this, but in the inspector, we click on the field next to mesh and click a box mesh resource to create a visible box. No way. It's not that simple. It can't be that simple. A box mesh? Oh man, there it is. That's pretty crazy. Once again, it's too small by default, so we got to click on the box icon to expand the resource and set its size to 60, 2, and 60. So we click on the box icon, 60 for the X, 2 for the Y, 60 for the Z. Oh my goodness. I don't know how to zoom out. I mean, we got a big floor now. That's awesome. Wait, I don't want to like mess stuff up. Okay, that's how you pan. Can I zoom out? Okay, there we go. Oh, there's a thing on the right. Okay. Whoops, didn't mean to undo that. Okay, we're good. We got a mesh. We got a floor. You should see a wide gray slab that covers the grid and blue and red axes in the viewport, which we do. We're going to move the ground down so we can see the floor grid. So we select the ground, hold Control key down to turn on grid snapping, and then we click and drag down on the Y-axis. It's the green arrow. Move the ground down to 1 meter in order to have a visible grid editor. There's a label at the bottom left that'll tell you this. Ultimately, the ground's transform position should be -1. Okay, let's give this a whirl and see how this goes. So we grab, is it really control though? It is, okay. There we go. And you can see it was down here at the bottom left. There was the little preview for what the axis is. So yeah, we're at -1, looking good. Man, we're almost already through this first chapter. We're cruising through this. So let's add a directional light to our scene. So our scene isn't all gray. So we select the main node, add a child node for directional light 3D. Then we need to move and rotate the light nodes. We're going to move it up by clicking and dragging on the green arrow and click and drag on the red arc to rotate around the X-axis until the ground is lit. And then we're also going to turn on shadow enabled by clicking the checkbox, and we should have something that looks like that. And that's our starting point. Okay, so let's finish this. So we're clicking on that's adding it to the main, right? Main, add light, and it was the directional light 3D. Make sure I'm adding the right one. Okay, and then move it up by dragging the green arrow. Great. And then the red arc to rotate the X-axis. So it's pointing down. And then we also need to go over here to shadow and click enable. Neat. It's really that simple, huh? Okay, we're done with the first chapter, the first step of the tutorial, whatever you want to call it. Setting up the game area is complete. So now we're on to player scene and input actions. So in the next 2 lessons, we will design the player scene, register custom input actions, and code the player movement. By the end, you'll have a playable character that moves in 8 different directions. We're going to create a new scene by going to the scene menu at the top left, clicking new scene. And this will be adding a character body 3D node as the root. Way to name it player. Character bodies are complementary to the area and rigid bodies used in the 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled by physics engine, you dictate the movement. You will see how to use the node's unique feature when we code the jump and squash mechanic. For now, we're going to add basic rig for our character's 3D model. This will allow us to rotate the model later via code while it plays an animation. Okay, let's do the first part first. Maybe getting a little ahead of myself, so we do new scene. Other node, character body 3D, create. Name the character body 3D to player. Done. I guess that was it. So now we just need to add a node 3D node as the child of the player. Name it pivot. So let's go ahead and do that. So node, 3D node, boom, and call it pivot. Great. Guess we'll figure out what that's gonna be for here in a second. Then in the file system doc, expand the art folder by double clicking it and drag and drop the player.glb onto pivot. This should instantiate the model as a child of pivot. You can rename it as character. Okay, that sounds pretty simple. Player over pivot. Whoa, that's crazy. And then what were we supposed to name it? Character. Right. Cool. We're moving right along. Oh, here's a nice note. The .glb file contains 3D scene data based on the open source GLTF 2.0 specification. They're a modern and powerful alternative to proprietary formats like FBX, which Godot also supports. To produce these files, we designed the model in Blender 3D and exported it to GLTF. Cool, that's great. I mean, I'm all for more open source stuff, less proprietary stuff. So that's awesome. So as with all kinds of physics nodes, we need collision shape for our character to collide with the environment. So we select the player node and add a collision shape 3D in the inspector. On the shape property, add a sphere shape 3D. The sphere will appear below the character. It will be the shape the physics engine used to collide with the environment. So we want to better fit the 3D model. Shrink it a bit by dragging the orange dot in the viewport. My sphere radius was about 0.8 meters. Then move the shape up so the bottom roughly aligns with the grid plane. You can toggle the visibility by clicking the model's visibility by clicking the eye next to the character or the pivot nodes. Save the scene as player. Cool. Okay. Let's do that real fast. So, so yeah, let's click on the character, and what do we? I'm sorry, now I'm all lost. Select the player node, and we're adding collision to the player node. See, I would have messed that up. And we're adding collision shape 3D, not 2D. We're done with 2D. We've graduated from that. And we're on to collision shape 3D. And then we go to shape and we're doing sphere shape, right? Yes, sphere shape 3D. That's not how I wanted that to rotate, but whatever. Because okay, I could just fly around. Oh, that's kind of fun. Okay. And then what else do we need to do? Appears below the character. So we need to like expand it first. Which it said it's like 0.8 for the radius. I'm just gonna set that. I'd like to be close to whatever they have. Okay, yeah, that seems pretty close. And then move it up so the bottom roughly aligns with the grid plane. We can hide the pivot and then move it up to see how we're looking. That looks pretty good. Oh yeah, that looks pretty good. And then we can show this again. Boom, man. I am learning. Slowly but surely. We gotta save the scene as player. Done and done. Okay, that looked like not like it was aligned, but I assume it is. Yeah, no, this seems fine. I think, I hope. Guess we'll find out. We're moving right along. With the nodes ready, we can almost get to coding, but first we need to define some custom input actions. To move the character, I'll switch back to this. I can read off of that. To move the character, we'll listen to the player's input, like pressing the arrow keys in Godot. While we could write all the key bindings in code, there's a powerful system that allows us to assign a label to a set of keys. This simplifies our scripts and make them more readable. So in the project settings, we're going to the system is the input map, which we used last time. So we're going to project settings, the input map tab allows you to add new actions at the top and assign keys to these actions. So Godot projects come with some predefined actions designed for user interface, which we can use here, but we're defining our own support gamepads. our own to support gamepad. So we're going to name our actions move left, move right, move forward, move back, and jump. To add the actions, you just add them like that. That will create 5 actions. And then we're going to bind the move buttons, the 4 moves, to all the arrow keys. But we're also going to bind A, so we can have WASD and the arrow keys, which is pretty cool. And we can go ahead and add controller support, even though I don't have a controller nearby to actually test with, but we can still add it. And then we're gonna do the same for all the other things. And the last one's gonna be jump, which is just gonna be spacebar or gamepad A. So let's go through and do all of this. It really shouldn't take too long. Famous last words. Project settings, input map. So let's add all of them first. So we have just all of the moves and jump. So we got move left, move right, move forward is what they call it, which I guess makes sense. Move back and jump. Great. So move left, we're going to bind left. Okay. Add another A. Okay. Add another. And we're going to do, let me make sure I do this right. So then for the joypad, we're doing manual selection, joypad axis. And then which one? Select the negative X axis on the left joypad. Oh, okay, yeah, it just says right here, yeah. Which is axis 0, negative, which is the left stick left. Okay. So then move right, right arrow, boom. Move right, D, boom. Move right, joypad axis. I assume this one's gonna be just, yeah, this is 0 positive. Just making sure I'm doing this right. Okay. Move forward, up arrow. Okay. Move forward, W. Okay. And then move forward, joypad axis, left stick up. Okay. Then we got move back, down arrow, boom, S, boom, and then joypad axis, the left stick down, boom, and then finally jump, spacebar, and then jump would be joypad buttons. Oh lordy, there's a lot of these. Where's the A button? Which one do we want? Joypad button 0. I like how it says joypad button 0, bottom action, Sony cross, X, A, Nintendo B. I know people have complained about this. This isn't a new complaint, but it's just so ridiculous that all controllers have like different, I mean, Sony has always had different controllers, but like Xbox, their A button's always on the bottom, X is on the left, Y is at the top, B is on the right, but then Nintendo had to put B on the bottom, switch up their whole thing, so it just makes stuff confusing, but whatever. I mean, clearly they account for that by just calling it bottom action, which makes sense, but yeah, that's all of them. So we are set up with our inputs. I'm gonna triple check that mine looks like theirs, but I think we should be pretty good. Yeah, that looks good. Sweet. This is going a little bit quicker than anticipated, but we're not really to the hard stuff yet. We haven't even done any coding, so we're about to with this new section, moving the player with code. It's time to code. We're going to use the input actions we created in the last part to move the character. So we'll right click on the character, select attach script, add a new script. In the pop-up, we set the template to empty before pressing the create button. Interesting. We haven't done that yet. So let me make sure I go to the new page on my other browser. Okay, so we click on player, click attach script, template And we just click object empty. And click create. Okay, so this starts as, with a completely empty object. All it has is the extends character body 3D at the top. So let's start with the class properties. We're going to define a movement speed, a fall acceleration that represents gravity, and a velocity that we'll use with the characters. So we're exporting a variable for speed, setting it to 14. So how fast the player moves in meters per second. Then we have the fall acceleration also exported, set to 75, which is the downward acceleration when in the air in meters per second squared. And then we have target velocity, which is just a vector 3 set to 0. So let's go ahead and add all that. Just pasting it in. I don't want to, too lazy to type it all out, but that's, it's all good. These are common properties for moving a body. The target velocity is a 3D vector combining a speed with a direction. Here we define it as a property because we want to update it and reuse its value across frames. Okay, sweet. These values are quite different from 2D code because distances are in meters, while in 2D, 1,000 units pixels may only correspond to half of your screen's width, but in 3D, it's a kilometer. Now, I'm American. I don't speak meters and kilometers. They need to update this. I'm just joking. Let's code the movement. So we start by calculating the input direction vector using the global input object in physics processes, which this is new. And this explains down here, we are making all of our calculations using physics processes virtual function. Like process, it allows you to update the node every frame, but it's designed specifically for physics-related code like moving a kinematic or rigid body. And it seems like they have docs listed for all this. So we're creating a direction, just a local direction, setting it to vector 3. Then we're grabbing the input if it's moved right. This looks very similar to what we were doing last time. It's adding the direction x plus 1. It's moving left, direction x minus 1. If the input is back, since we're using x and z, since we're in 3D land, that's z plus 1, and then moving forward is z minus 1. Which that does seem a little backwards, but I believe them. I'll take their word for it. So let's go ahead and add this in, like so. That's all indented correctly, so sweet. As it kind of explains here, we're initializing direction to vector 3, 0. Then we check if the player is pressing one of the or more of the moves, and inputs the vectors x and z components. These correspond to the ground plane's axes. Sweet. These 4 conditions give us 8 possibilities and 8 possible directions. So in the case the player presses, say, both W and D, the vector will have a length of about 1.4, but if they press a single key, they'll have a length of 1. This is something we ran into last time, so we want our vector's length to be consistent and not move faster diagonally. So to do this, we have to call the normalized method. And this looks very similar to what our 2D code, that if their direction is not a vector 0, then we take the direction and we normalize it, and then we set the basis of the pivot, and we set it to basis.looking at with our direction as the parameter. So as it says here, setting the basis property will affect the rotation of the node. And yet here we only normalize the vector if the direction has a length greater than 0, which means the player is pressing a direction key. We compute the direction of the pivot that the pivot is looking by creating what's called a basis that looks in that direction. Cool. Let's paste this in. And this just gets added down here. Sweet. We're chugging along. This page looks long, but I imagine this is, it's making the player character move. This is probably a lot of code and whatnot. So then we have to update the velocity. So we have to calculate the ground velocity, then the fall speed separately. Be sure to go back 1 tab so the lines are inside the physics process function, but outside the condition we just wrote above. So looking at the new code, for ground velocity, we take the target velocity.x, times it by direction.x, times our speed. Target velocity.z is direction.z times speed. That's our ground velocity. Then we have our vertical velocity. So first we check if we're not on the floor by doing if not is on floor. So if we are in the air, we fall towards the floor, literally gravity as it puts there. And we do this by setting the target velocity y by equal to the target velocity y minus whatever our fall acceleration is times delta. And delta was explained in our last 2D tutorial that's just used to make smooth movements. It calculates how long it took the last frame to run, so then your physics aren't based on frame rate, essentially. And then we move the character by setting velocity equal to target velocity, and we call the move in slide function, which I don't know if that's a built-in function, but never heard of that, but we'll see how that works. So the character body 3D dot is on floor function returns true if the body is collided with the floor in this frame. That's why we apply gravity to the player only when it's in the air. For vertical velocity, we subtract the fall acceleration multiplied by the delta time every frame. This line of code will cause our character to fall in every frame as long as it's not colliding with the floor. The physics engine can detect interactions with walls and the floors or other bodies during a given frame. If movement and collision happens, we will use this property later to code the jump. On the last line, we call character body.move and slide. Okay, that's a function of the character body, I guess, which is a powerful method of the character body that allows you to move a character smoothly. If it hits a wall midway through motion, the engine will try to smooth it out for you. It uses the velocity value native to character body 3D. That's all the code you need to make the character move on the floor. Really, that's it? I don't believe it. If you say so. So let's add this to our physics. Make sure the indentation is not all out of whack. That looks good. Here's the entire reference for this file. Ooh, we get to test out the player movement. Okay, here we go. So we're going to put our player in the main scene to test it. To do so, we need to instantiate the player and then add a camera. Unlike in 2D and 3D, you won't see anything in your viewport if you don't have a camera pointing at something. So we save our main player scene, open the main scene. If you close the scene before, yada, 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 you can reopen it. And then to instantiate the player, you click on main, click on the little lock symbol, or you can right click it and instantiate child scene, click the player scene. So let's go ahead and do that before I get too far along. Updating my other, okay. So go back to the main scene, which for some reason isn't saved. We click on main, instantiate, player, open, and that's it. Sweet, okay. So then we need to add a camera. Curious how difficult this will be. So let's add a camera next, like we did with our player pivot. We are going to create a basic rig. So right click on the main and select add a child node. We're going to create a marker 3D, call it camera pivot. Select the camera pivot and add a child node of camera 3D. Our scene should look something like this. Okay. So click main, add child, and we're doing a marker 3D. Boom. Calling it camera pivot. And then with that selected, we add a camera 3D to it. And our scene should look something like that. Let me double check. My scene looks pretty correct. And so far it does. Fantastic. All right. We're cruising. I'm very anxious to test this out and see how this works. Notice the preview checkbox that appears in the top left when you have a camera selected. You can click it to preview the in-game projection. What? Where? When you have this selected, the preview box. What preview box? I don't see. Wait, do I have to go back to the 3D scene? Oh, up here. Okay. Well, I guess we haven't moved our camera, so right now this looks like the bottom of our character model. That's cool though. Neat. So we're going to use the pivot rotate we're going to use the pivot to rotate the camera as if it was on a crane. Let's first split the 3D view to be able to freely navigate the scene to see what the camera sees. So in the toolbar above the viewport, click on View, then 2 viewports. Okay. View, 2 viewports. Oh, that's kind of cool. All right. On the bottom view, select your camera 3D, turn on the camera preview by clicking the checkbox. Great. In the top view, move the camera about 19 units on the X or the Z axis. The blue one. The blue one? 19 units? Oh, okay, there it is over there. 17, 18. And we're okay, 19. A little bit over, but that's okay. Here's where the magic happens. Okay, let's see this. So we have to set the camera pivot and rotate it negative 45 degrees around the x-axis. You'll see the camera move as if it were attached to a crane. The red circle, negative 45 degrees. Negative 45 degrees. I am looking at the ground. Oh, okay, my bad, because I have to select the camera pivot, not the cam. Was I supposed to move the camera pivot or the camera? Oh, shoot. Oh, it does say move the camera, and then we move the camera pivot. Negative 45 degrees. Oh, whoa, okay. All right, now we're getting somewhere. This is cool. All right, I'm following. You can run the scene by pressing F6 and press the arrow keys to move the character. Let's see if that actually happens. We'll just select current. Let's see how this works. Okay, we got a scene here. Let's see what happens if I use the arrow keys. Oh man, look at that. We can like move diagonally and everything. Heck yeah. What happens if I go off the ground? Do I fall? I do fall. That's awesome. Look at that. We got a working 3D game. Well, not a game, but it's doing something. You see some empty space around the character due to perspective projection. In this game, we're going to use an orthographic projection instead to better frame the gameplay area and make it easier for the player to read distances. So we select the camera again in the inspector, select projection to orthogonal, and in the size to 19. The character should now look flatter, and the ground should fill in the background. Okay, let's go ahead and do that. Hold on. Okay, so camera. Then over here, is it the projection? Where's here it is. Perspective to orthogonal. Oh, geez. Okay, and then size. Got really zoomed into perspective here to 19. Okay. All right. Test your scene. You should be able to move in all 8 directions and not glitch through the floor. Ultimately, we have player movement and the view in place. Next, we will work on the monsters. Let's give this another whirl because I'm curious to see how this looks with the new camera. Make this nice and big. Oh, that's awesome. Oh man, that's really cool. Oh man, this is pretty sweet so far. Look at that. Nice. We're getting somewhere. Maybe slowly, but we're on our way. We are on our way to the next step, which is designing the mob scene. I'm gonna take a quick sip of water here. So, in this part, you're going to code the monsters, which we'll call mobs. In the next lesson, we will spawn them randomly around the edge of the playable area. Let's design the monsters themselves in a new scene. The node structure is going to be similar to the player scene, so create a new scene. Once again, a character body 3D as its node, name it mob, add a child node. 3D, name it pivot, drag and drop the mob GLB onto the pivot to add the monster's 3D model to the scene. You can rename the created mob node into character. It should look something like this. Let's go ahead and do that. So, excuse me, we're gonna create new scene. A character body 3D as the base node. We're going to name it mob. Let's go ahead and do that. Add a child node 3D. Okay. And we're going to name that pivot. And then we drag and drop the mob GLB onto pivot. Okay, I think I messed that up. I didn't do that. Drag that onto pivot. There we go. And then it said we could change the file name to character. Cool. Which mine does look like theirs. So we're on a roll so far. Okay, so now we need to add a collision shape for our body to work. So we right click on the mob node, and which is the scene's root, add child node, add a collision shape 3D. In the inspector, we're gonna assign a box shape 3D to the shape. You should change the size to fit the 3D model better. You can do so interactively by clicking and dragging. The box should touch the floor and be a little thinner than the module. Physics engines work in such a way that if the player's sphere touches even the box's corner, a collision will occur. So if the box is a little too big, you may die at a distance from the monster, and the game will feel unfair. Notice the box is taller than the monster is okay in this game because we're looking at the scene from above and using a fixed perspective. Collision sphere or shapes don't have to match the model exactly. It's the way the game feels when you test it that should dictate their form and size. Okay. Fair enough. Let's get going on this part. So we're adding the collision. So we click on the mob, right? Yeah, the mob, add collision shape 3D. And we don't think we rename it. We just select the shape being, what was it? The new box shape 3D. Okay. And now I can't even see it. Okay, there it is. So we want to move it so it's off the ground. Or it's just like touching the ground. Why does that look like it's above? Or is that just my perspective? Is that below? No, I can't tell. No, that looks like it's on the ground. Okay, and then we need to enable this. Okay, let's fly around a little bit. So we need to make this a bit, whoops, not that. Grab that. There, we'll add it like a little bit. No, I meant to grab this thing. There we go. Something like that. And above here, we're gonna go like at least to the outer part of the eye. That feels like up top it's too much. It's definitely too much. Something like that. That feels too much. This feels a little bit much. No, wrong thing. Something like that. I guess that's pretty close. Yeah. I think I need to also shrink it to be like, no, I keep clicking the wrong thing. There we go. Something like that. Okay. All right. We're getting somewhere. It's not the best box collision in the world, but like I said, it doesn't need to be exact. Oops. I guess I could just save this, but whatever. So Now we need to remove the monsters off screen. So we're going to spawn monsters at regular time intervals in the game. If we're not careful, their count could increase to infinity, and we don't want that. Each mob instance has both a memory and a processing cost, and we don't want to pay for it when the mob is outside the screen. So once a mob leaves the screen, we don't need it anymore. We should delete it. So Godot has a node for that detects when an object leaves the screen. We use something similar in the 2D tutorial. This one is called Visible On-Screen Notifier 3D, and we're going to use it to destroy our mobs. Note, when you keep instancing an object, there's a technique you can use to avoid the cost of creating and destroying instances all the time called pooling. It consists of pre-creating an array of objects and reusing them over and over. So when working with GD script, you don't have to worry about this. The main reason to use pools is to avoid freezes with garbage collected languages like C# or Lua. GD script uses a different technique to manage memory reference counting, which doesn't have that caveat. I did not know that. That seems like a pretty big benefit for GD script, because having to do with stuff with a garbage collection, though I haven't done a whole lot in my experience. That's something I've studied a bit. I've read about, and so that's kind of cool that you don't have to worry about that. That's sweet. So we got to just click on the mob node, child node, add visible on-screen notifier 3D. Another box, pink this time, will appear. When this box completely leaves the screen, it will emit a signal. We want to resize this until the orange dots cover the entire 3D model. So let's go ahead and do that. Mob, add, notifier, visible. It's visible, right? Visible on-screen notifier 3D. It's quite the mouthful of a name. Oh god, this is the resetty theme. Skip. I'm gonna figure out better music for next time. I just want something chill. Sounds like, oh, Animal Crossing for sure is pretty chill. I guess this part doesn't really matter if it's close to the bottom, but let's go ahead and make sure that's good. That part's actually, the width isn't too bad. Just gotta make sure this part, no, I don't want the arrow. And we want it to shrink down. Oh, that messes up both. I didn't realize this is like that. I didn't realize it was like that. I guess that's not a huge deal. All right, I'll make this a little bit bigger. I don't want to spend too much time on this, but I want to get it right. I keep clicking the wrong button. I don't want the arrow, I want the dot. Why can't I grab the dot? Give me the dot. Why is it moving the arrow? There we go. Honestly, the y-axis doesn't really even matter, but I don't know. I like to try to get it close. Okay, that's pretty good. It doesn't need to be exact, but that's actually not too bad, I would say. Okay, we are cruising along, and we're on to coding the mob's movement. So, let's implement the monster's motion. We're gonna do this in 2 steps. First, we'll write a script on the mob that defines a function to initialize the monster. We'll then code the randomized spawn mechanism in main and call the function from there. And we're going to start by attaching a script to mob. Here's the movement code to start with. We'll define 2 properties, min speed, max speed, to define a random speed range. We will use later to define the velocity of the character body. So we have min speed of 10, max speed of 18, and in the physics process, we are just doing the move and slide. So I'm just gonna straight up copy this whole thing into the mob script, which we haven't created yet, but it's simple enough. We go boom, boom, object empty seems like what we want, and paste that in. Great. Similarly to the player, we move the mob every frame, calling the move and slide function. This time we don't update the velocity every frame. We want the monster to move at a constant speed that leaves the screen, even if it were to hit an obstacle. So we need to define another function to calculate the velocity. This function will turn the monster towards the player and randomize both its angle of motion and its velocity. This function will take a start position, which is the mob's spawn position, and the player's position as arguments. We position the mob at the start position and turn it towards the player using look at from position method. And then randomize the angle by rotating a random amount around the y-axis. Below, we use the random f range to output a random value between negative pi over 4 radians and pi over 4 radians. Man, they love using this pi over 4 radians. So this is the initialize function, which takes in start position, player position. We position the mob by placing it at the start position. We rotate it towards the player position, so it looks at the player. So we call look at from position, start position, player position, and the vector 3 up. And then we rotate the mob randomly with negative 45 to plus 45 degrees so that it doesn't move directly towards the player, which is kind of nice. So we will copy and paste that over. Just down here, easy enough. Save, tab back. We got a random position, and now we need a random speed. So randy range will be useful as it gives a random interval values, not interval, integer values, and we will use min speed, max speed for that. So random speed is just an integer. We will use it to multiply our velocity. So after random speed is applied, we can rotate the velocity vector towards the player. So we're adding onto our initialize function that we're making random speed be a random integer from min to max. Velocity is velocity forward, or vector 3 forward, times random speed to get our velocity moving. And then we rotate the velocity vector based on the mob's y rotation in order to move in the direction the mob is looking. So velocity dot rot equals velocity dot rotated with vector 3 up and rotation dot y. So let's go ahead and add this all to this initialize function. It's getting to be quite the function, but luckily they have plenty of comments, and so far it's mostly making sense. Some of the vector stuff is a little weird to me, but you know, I'm just hoping it'll click in here soon, but I think it makes sense for the most part. So leaving the screen, we still have to destroy the mob when it leaves the screen. To do this, we'll connect our visible on-screen notifier 3D to the node's screen exited signal to the mob. Head back into viewport, click on the 3D label, select the visible on 3 notifier node, navigate to the node dock, double click screen exited signal, connect the signal to the mob. This will take you to the script editor, add new function. From it, call queueFree method. This function destroys the instance it's called on. So let's go ahead and do that. So go back to the 3D view, click on visible on-screen notifier, over here to node, signals, screen exited, call that on the mob, click connect, adds our new function, and then we just call, what was it, queueFree, right? Yeah, it's just queueFree, which, like it says, just that's how you destroy an instance. And that's the mob script, I guess. We're on to the next step, which is spawning the monsters. We're it's like halfway through this 3D. Yeah, we're like halfway through this 3D. Oh, it take a quick stretch. Oh man, this is fun. I'm liking Godot the more I'm using it, and like I said, this is the first time me messing with 3D stuff, but it's pretty cool. And not as complicated as I thought, but okay, I don't like this song either. Let's go back to there we go. Back to the beginning. More Animal Crossing music. So, here we go. Spawning monsters. In this part, we're going to spawn monsters along a path randomly. By the end, you'll have monsters roaming the game board. And it seems like we're probably going to do something pretty similar to what we did in 2D, where we create a path along the border, and then like find the random position, and then angle it in, and then all that good stuff. So we're going to start by Clicking on main to open the main scene. We're gonna have to change the game's resolution. Our game has a default window size of 1152 by 648. We're gonna set it to 720 by 540, a nice little box. So we go in the project settings, display, window, and we change the settings there. So let's go ahead and do that real fast. So let's go back to the main scene. Let's open up the 3D view. Up here on project settings. Go to general, display, window. The width should be 720 and the height, good old 540. Nice, all right. Time to create the spawn path. So like you did in the 2D tutorial, I figured this is how we're gonna do it. You're gonna design a path and use a path follow 3D node to sample random locations on it. In 3D though, it's a bit more complex to draw the path. We want it to be around the game view, so monsters appear right outside the screen, but if we draw the path, we won't see it from the camera preview. To find the view's limits, we need some placeholder meshes. Your viewport should still be split into 2 parts, with the camera preview at the bottom. If it isn't, shows you how to do it. Select the camera 3D node and click the preview. So yeah, we're good. We still have that set up from last time. Adding placeholder cylinders. So let's add placeholder meshes. Add a new node 3D child to main and name it cylinders. We're going to use it as a group. Use it to group the cylinders. Select cylinders and add a child node mesh instance 3D. Okay. So main, new node, node 3D. I'm gonna call it cylinders. Make sure I spelled that right. Then we select that, add child node, and doing mesh instance 3D. Okay. In the inspector, we're going to assign a cylindrical mesh to the mesh property. Over here in the inspector, mesh. Where is it? There it is, cylinder mesh. Cool. Then we set the top viewport to the top orthogonal view using the menu in the viewport's top left corner. Huh? Viewport and is that this? No. Using the menu in the viewport's top left corner. I'd like to know how to do this because I mean, it has some key binds you can do, but is it perspective? Top view. Okay. Yeah, that's the little dot perspectives up there. Okay. The grid may be distracting. You can toggle it by going to the view menu in the toolbar and clicking view grid. Okay, I can barely see the grid, so it's not that distracting, but we can turn it off, I guess. You now want to move the cylinder along the ground plane, looking at the camera preview in the bottom. I recommend using the grid snap to do so. You can toggle it by clicking the magnet icon in the toolbar or pressing Y. Which that's this. Move the cylinder so it's right outside the camera's view in the top left corner. I see. I don't know why I can see past this. I don't know if it's just because my screen's wide. Oh, I think it is. I guess it doesn't really matter. So something like that. I think that's what I'm supposed to do. It looks pretty close to what they have here. You just move it to the top left corner. We're going to create copies of the mesh and place them around the game area. So Command D or Control D to duplicate the node. You can also right click in the scene, select duplicate, move the copy along the blue Z axis till it's outside the camera's preview. Select both cylinders by pressing the shift key, clicking on the unselected one to duplicate. Move them to the right by dragging the red axis. It's hard to see in white, aren't they? Let's make them stand out. Okay, well, hold on. Should I have been moving the mesh instances around instead of the cylinders? I guess it probably doesn't matter. So Command D duplicates, and then we're moving it first along the blue Z axis. It's like down there. And then we select both of them. We do Command D, and then move them off to the right. Which I can't really see. Something like that. That seems pretty good. But yeah, we can't really see them. So let's make them stand out by giving them a new material. In 3D, materials define a surface's visual property, like color, how it reflects light, and more. We can use them to change the color of the mesh. We can update all 4 cylinders at once. Select all the mesh instances in the scene dock. Click on the first one, shift, and then click on the last one. In the inspector, expand the material section and assign a standard material 3D to slot 0. Okay, so clicking all of the mesh instances, the inspector, was it the material or the mesh? Expand the material section. Ooh. Where's the material section? I do not see material section. Am I blind? Where do I click this? Oh, and then... Wait, what? Uh-oh, I'm a little confused. Expand the material section and assign a standard material 3D to slot 0. Oh, this is the material section. And then a new standard material to okay. Okay. Figured it out. It just took me a second. My bad. Click the sphere icon to open up the material resource. Okay. This is pretty interesting. You get a long list of sections filled with properties. You can use these to create all sorts of surfaces, from metal to rock to water. Expand the albedo section. Why aren't these in alphabetical order? Whatever. Select the color to something that contrasts like a bright orange. Oh gosh. So you have to try to create orange now. Okay, there we go. That seems good. We can now see the cylinders as guide. Fold them into the scene by clicking the dock. Boom. Moving forward, you can also toggle their visibility by clicking the eye icon. Which I guess, do we not really need them anymore right now? Okay, that's kind of cool. Whew. So we're about to add the path, it looks like. So we just went through all of this, all of that, all of that. Now adding a child node path 3D to the main node in the toolbar. 4 icons appear. Click the add point. This is the green plus icon. And we click in the center of each cylinder to create a point, then click close curve in the toolbar to close the path. If any point is a bit off, you can click and drag it to reposition it. Your path should look something like this. Let's see if that actually happens or not. So to main, we first have to add the path 3D node, which we can easily do. And then we click on the, ooh, what did I do? Oh, I guess I changed the perspective, didn't I? I just wanted to zoom in a little bit. Is that not possible? Yeah, I guess I can probably do it from here. So I click on that, that, and then close curve. Killing it. All right. Nice. So to sample random positions on it, we need a path follow 3D node. So we add it as a child of the path 3D, and we can rename these nodes to spawn location and spawn path respectively. It's more descriptive. It's more descriptive of what we use them for. Makes sense. So we choose our path 3D, add child node, path follow 3D. Add that. We name the top one spawn path. And then this one is spawn location. Okay, this is starting to make sense. With that, we're ready to code the spawn mechanism. Oh boy. This shouldn't be too bad, right? Surely. So you right click on main, attach on the main node, and attach a new script. We first export a variable to the inspector we can assign mob or any other monster to. So let's go ahead and copy this, go back, main. We haven't created a main script yet? That's kind of crazy to think. We've made it this far. I'll just go with the default node template. It doesn't say to, but it doesn't say not to. I don't know if I should just make all of them empty, but we'll keep with this for now. Add in the extends, add in the mob scene variable, and then let's continue onward. So we want to spawn mobs at regular time intervals. To do this, we need to go back to the scene, add a timer. Before that, though, we need to assign the mob file to the mob scene property, otherwise it will be null. So we head back to the 3D scene, click the main node, drag the mob from the file system to the slot in the inspector, which is pretty dang simple. 3D scene, click the main. Over here in the mob scene, we just grab the mob scene file and drag it over here. Cool. And then now we add a new timer as a child of main. Boom, boom, timer. I hardly know her. Just joking. We'll name it mob timer. Okay. So in the inspector, we set its wait time to ½ second. And turn on auto start. So it automatically starts when we run the game. Simple enough. Cool. What next? So timers emit a timeout signal every time they reach the end of their wait time. So by default, they restart automatically, emitting the signal in a cycle. We can connect to the signal from the main node to spawn monsters every ½ second. With the mob timer still selected, we head to the node dock on the right, double click the timeout signal, connect it to the main node. This will take you back to the script with a new empty on mob timer timeout function. Let's do that first, and then we'll get into the actual logic of this. So mob timer selected, node tab, double click timeout, click connect. Super simple. I'm really starting to dig these the signals, and like connecting them up to scripts is super easy and pretty dang intuitive, and I can see how it's makes stuff a lot easier. Okay, so let's code up this script. So we are going to instantiate the mob scene, sample a random position on the spawn path, get the player's position, call the mob's instantiate method, passing it a random position and the player's position, and then we add the mob as a child of the main scene. And I guess this is some of the code, or maybe all the code to do that. Yeah. So we create the mob instance and we call it mob. Then we choose a random location on the spawn path. We store it. We store the reference to the spawn location. So mob spawn location is just get node of spawn location on the spawn path. Then we give it a random offset. So the progress ratio is just a random float. The player position is just the player instance position, or the scene position, whatever you want to call it. And then we do mob.initialize, which that was something we created earlier. Remember this big old function? Yeah, that's coming back right here, where we take the spawn location position and the player's position, and then we just add the child, which adds it to the main scene. Simple as that, really. And this, I'm gonna copy it like this. Not that it probably really matters, but whatever. Okay, above, yeah, random float produces a value between 0 and 1, which is what the path follow node's progress ratio expects. 0 is the start of path, end is 1. The The path we have set is around the camera's viewport, so any random value between 0 and 1 is a random position along the edges of the viewport. Here's that. We can test the scene by pressing this. You will see mobs spawn and move in a straight line. For now, they bump and slide against one another. When their paths cross, we'll address this in the next part. Let's see if that actually works. I'll be shocked. They do. They just kind of stop. That's funny. Look at that. We got mobs. Oh man. Can I like break this up? No, they're just like, that's like a wall of mobs. That's kind of funny. I could just stop them dead in their tracks. This is a fun game. This is super fun. It's not really a game yet, but you know what? We're getting somewhere, dang it. We are on to jumping and squashing monsters. We have 1, 2, 3, 4, 5 sections left. We're already at 3 hours. This is gonna be a 4-hour stream at least. That's okay. I'm having a good time. Hope everybody that's watching is having a good time. And yeah. Let's hope we can finish this here relatively directly. I mean, it feels like we got a lot of the hard work done. We got the mobs spawning, the mobs moving, the players moving. We just got to jump and squash the monsters, figure out killing the player, score and replay, character animation, and then maybe we'll skip whatever the going further section is. But we'll see, you know, how we're doing on time and what that all entails. But yeah. Take a quick sip of water. I've been talking a lot here. Jumping and squashing monsters. So in this part, we'll add the ability to jump and squash the monsters. In the next lesson, we'll make the player die when a monster hits them on the ground. So first we have to change a few settings related to physics interaction. Enter the world of physics layers. Oh boy, buckle up. So controlling physics interactions. So physics bodies have access to 2 complementary properties, layers and masks. Layers define on which physics layer an object is. Masks control the layers that a body will listen to and detect. This affects collision detection. When you want 2 bodies to interact, you need at least one to have a mask corresponding to the other. If that's confusing, don't worry. We'll see 3 examples in a second. Okay, that was kind of confusing, but you know what? I'm ready for these 3 examples. So the important point is that you use layers and masks to filter physics interactions, control performance, and remove the need for extra conditions in your code. By default, all physics bodies and areas are set to both layer 1 and mask 1. That means they all collide with each other. Physics layers are represented by a number, but we can give them a name to keep track of what's going on. So let's get into setting a layer's name. Let's give our physics layer a name. Go into project settings. And then in the left-hand menu of General and Layer Names, there's 3D Physics. See a list of layers with a field text next to each of them on the right. You can set their names there. Name the first 3 layers to players, enemies, and world, respectively. Okay, respectively. So let's go ahead and do that. Hop back here, project settings, general, layer name, 3D physics. Layer 1 will be player, layer 2 will be enemies, and layer 3 will be world. Cool. Now we can assign them to our physics nodes. Where are we? Okay. So assigning layers and masks. So in the main scene, select the ground node in the inspector, expand the collision section. There you can see the node's layers and masks as a grid of buttons. The ground is part of the world, so we want it to be part of the 3rd layer. Click the lit button to toggle off the 1st layer and toggle on the 3rd, then toggle off the mask by clicking on it. Simple. Let's do that. So let's get out of here. In the main, we click on ground, go back to the inspector, and then under the collision object in the collision 3D section, uncheck that, and we check layer 3. Okay. which I guess if you hover over it, it does say world. I was like, I wish it said the names. Yeah, if you hover over them, it does. That's kind of nice. Cool. So where are we at? So as mentioned before, the mask property allows the node to listen to interactions with other physics objects, but we don't need it. We don't need it to have collision. So ground doesn't need to listen for anything. It's just there to prevent creatures from falling. Note that you can click the triple dot buttons on the right side of the properties to see a list of named checkboxes. Oh, that is really nice. Oh, yeah, that's cool. Neat. I'm learning more and more as I go along. So next up are the player and the mob. So open the player scene by double clicking it and then select the player node, set its collision mask. Set its collision mask to both enemies and world. You can leave the default layer property as is because the first layer is the player layer. That's kind of it's a weird phrase, the player layer. So let's save main, go back to player selected. Over here, collision, character body, collision. And then what was it again? The masks to both, we'd want to take it off 1, 2, and 3. I guess we could probably leave 1 on, but it doesn't, we probably want to take it off because that's just the player mask. And then we leave 1 on because that's the player layer. And then we save that. We go to the mob scene, select mob under character body, under collisions. We set, what are we doing here? Set its collision to the layer to enemies and unset its collision masks, leaving the masks empty. So mask empty, collision layer 2. These settings mean the monster will move through one another. If you want the monsters to collide and slide along each other, turn on the enemy's mask. Mobs don't need to mask the world layer because they only move on the XY plane. We don't apply any gravity to them by design. Cool, so now we're getting into jumping. The jumping mechanic itself requires only 2 lines of code, really. That's kind of surprising. Open the player script. We need a value to control the jump strength and update the physics process to code the jump. So after the line that defines fall acceleration at the top of the script, add the jump impulse and set it to 20. We can add in the little comment there that vertical impulse applied to the character upon jumping in meters per second. So we go save the mob, go back to the player, below the fall acceleration, add a new jump impulses. Cool. So then inside the physics processes, inside the physics processes, add the following code before the move and slide code block, which is the jumping. So it says if you're on the floor and the input is action just pressed of jump. So if the jump button is pressed and you're on the floor, target velocity.y is jump impulse. And that's all you need to jump. That is surprising. That is only 2 lines of code. I guess technically 3 if you count the variable declaration, but I'll let that slide, or should I say move and slide? I get it, because that's the name of the function there. And that's all you need to jump. So is on floor is a tool from character body class. It returns true if the bodies collide with the floor. That's why we apply gravity to the player. So when we collide with the floor, instead of floating over it like the monsters. So if the character is on the floor and they press jump, we instantly give them a vertical speed. In game, you really want controls to be responsive and give instant speed boosts like these. While unrealistic, it feels great. Okay. Notice that the Y is positive upward. That's unlike 2D where Y is positive downward. Right. Okay. Sure. Squashing the monsters. Okay. Man, we're flying through this. Let's add the squash mechanic next. We're going to make the character bounce over monsters and kill them at the same time. So we need to detect collisions with a monster to differentiate them from collisions with the floor. To do so, we can use Godot's group tagging feature. Open the mob scene again, select the mob node, go to the node on the dock, on the right to see a list of signals. The dock has 2 tab signals, which we already used, and groups, which allows you to assign groups. So we click on it to reveal a field. We can write a tag, and we're going to add mob as the field and click add. Then we should see a little icon here that indicates this node is part of at least one group. So boom, mob, here, node, groups, add tag, mob, add. Sweet. Super, super simple. We can now use this group from the code to distinguish collisions with the monsters from collisions with the floor. Great. So now we get to actually code the squash mechanics. We head back to the player script. At the top of the script, we need another property called bounce impulse. When squashing an enemy, we don't want to necessarily, we don't want the character to go as high when jumping. So we have a bounce impulse variable. That's the vertical impulse applied to the character upon bouncing over a mob. Cool. So back to the player. Below the jump impulse, we add this. Boom. Then after the jumping code block, we added above in the physics process, add the following loop with move and slide. Godot makes the body move sometimes multiple times in a row to smooth out the character's motion. So we have to loop over all collisions that may have happened. In every iteration of the loop, we check to see if we landed on a mob. If so, we kill it and bounce. With this code, if no collisions occur on a given frame, the loop won't run. Oh boy, that's a chunky line of code. So let's parse through it, and then I'll read the description at the bottom. So we have first line here that says iterate through all collisions that occurred in this frame. So for index in range of get all collision count, index is the name of the, I guess, specific collisions. Then we set a variable called collisions and set it equal to get slide collisions of index. So we get one of the collisions with the player. So this just gives us the index. This gives us the actual collision. Then if the collision.getCollider equals null, so if the collision is with the ground, we just continue, which means we pop out of the for loop. Or we don't pop out, we're done with that loop of the for loop. If the collider is with a mob, which is if collision.getCollider.isInGroup of mob, then we grab the mob, which is collision.getCollider, which I guess getCollider gets what you collided with. So that's why we check if it's null. If we didn't collide with anything, it's just continued. But if not, we set it equal to mob. We check that we are hitting it from above. So if vector3.up ... the dot function with the parameter of collision.getNormal is greater than 0.01. So this is how we check if we're hitting it from above. And then if so, we squash it and bounce by mob.squash, target velocity.bounce impulse, and we break, which prevents further duplicate calls. Boy, oh boy. So let's read through this bottom part because that seems to probably explain a bit more what's going on there. There's a lot. I think I mostly understand it. This from above is a little confusing. So the function get slide collision count and get slide collision both come from character body class and are related to move and slide. So get slide collision returns a kinematic collision 3D object that holds information about where and how the collision occurred. For example, we can use get collider property to check if we collided with a mob by calling isInGroup. So that's why we do collision.getCollider.isInGroup. The method isInGroup is available on every node. That's good to know. Sweet. So then to check if we are landing on a monster, we use the vector dot product of vector3.up ... with collision.getNormal greater than 0.01. So this collision normal is a 3D vector that is perpendicular to the plane where the collision occurred. The dot product allows us to compare it to the up direction. With dot products, when the result is greater than 0, the two vectors are at an angle of fewer than 90 degrees. A value higher than 0.1 tells us that we are roughly above the monster. Interesting. It's definitely a little confusing, but that explanation helps. After handling the squash and bounce object, we terminate the loop early via break statement to prevent further duplicates called to mob squash, which may otherwise result in unintended bugs, such as counting the score multiple times for one kill. We are calling one undefined function mob squash, so we have to add it to the mob class, which we're going to do right here, I guess. So I'm gonna paste this all in. That's quite the bit of code, and it looks like, yeah, we're adding this after the jumping block, I guess before the move and slide. So let's switch back here. So jumping is here. I think we add it here. It might go below move and slide. I think it goes above. Oh my god, that's so much. That's a thick line of code. That's not just a line. That's like that's a whole block of code. Yeah, wait, I'm gonna add in the little comment too, just to so we have some comments in there. So now we need to go back to the mob script, double clicking on it. At the top, we want to add a new signal called squashed. Nice. And at the bottom, we add a squash function where we emit the signal and destroy the mob. Seems pretty simple. Mob, well, I like putting the signals at the very top above the variables. I don't know if that's like standard in Godot world, but that's what I'm doing. And then we add the squash function, which literally just emits the squash signal and then does the queue free, which just, yeah, deletes the mob essentially. Whew. I need a quick break after that. My goodness. Okay, so we use the signal to add points to the score in the next lesson. With that, you should be able to kill monsters by jumping on them. You could press to test it and set main as this project's main. However, the player won't die yet. We'll work on that in the next part. Okay, let's see if this works. I'm very curious. Player shouldn't die yet. Good. So let's see if we can see if I can actually can I squash one, please? These guys are hard to hit. Maybe I did mess it up. I can't land on a single one. Give me an easy one. Okay, I think something's messed up because I'm not bouncing. I feel like I'm landing on them pretty good. Uh-oh, we got a bug. Oh no. Something's not working. I'm definitely hitting some. None's being squashed. Okay. Let me try one thing because I wasn't sure about this. Let me try doing move and slide first and then doing this after. I don't think that's the case. I think it has something to do with incorrect layers or masks, but let me see if this fixes it because I'm not sure if that's what I should be doing or not. Okay. I don't know if this is making a difference or not. Uh-oh. Oh no, we're gonna have to troubleshoot here. Nothing's happening. Okay. Troubleshooting time. Okay. Squash is defined. Function squash, it just emits. Squash runs here. The mob is grabbed from the collision. Let me go back and make sure I feel like some of my masks or players aren't right. So this collides with enemies and the world. It's on layer 1. This is mask 3 for the world, no collisions. Mob is layer 2. And that shouldn't be with anybody, right? Let me double check. Player's good. The mob only has layer 2. Okay, is there like console.log? Is there some sort of debug.log? Is there like a debug? Print debug, is that what I want? Let me see if this works, hold on. Uh-huh, okay. So print debug does kind of do what I thought, kind of. So what we want is then collisions. We want to see if we get past this. I mean, I straight up copied the code, so I don't think I have a typo anywhere, but I think that's why I'm more thinking it has something to do with masks, but I already checked that. Is the player supposed to collide with the world? It is. It says mask to enemies in world. That doesn't feel right though. Like, why would we need a mask with the world? Oh, I guess for the is ground, and then mob does have the group of a mob, right? That's on the top player, the mob object. Oh. I might need to like download the final script and see what it looks like. And what's nice is sometimes on this tutorial, they'll add at the end, like, here's the full script, but they didn't do that for this page, which sucks. So what I might do is take another quick break, try to troubleshoot this when I get back, because I gotta hit the restroom. So I'll be back in like, literally like, I don't know, a minute or two. So yeah. All right, let's do some troubleshooting. This is gonna be fun. By fun, I mean not fun. So first thing I want to see is if these colliders are actually happening with the mob. So I'm gonna put a debug there for collision, that whenever okay, something's wrong somewhere, because we're definitely not even, because even if we run into the mob, the collision should be happening. So what we can maybe do is we can debug the collision.get collider and see what that gives us. I'm curious. I think this will just keep spamming ground, because for some reason ground is... I don't know what ground is. I'm going to remove ground as a mask for the player, because I feel like that just... Maybe I'm going to fall through the floor now, but I mean, that shouldn't affect physics. It's only... Okay, I do just fall through the floor. Great. I think it has something to do with also, I noticed the mobs are coming in like tilted. And I don't think they're supposed to be like that. Like some of them are like clipping through the floor. And that might be messing up their hitbox. I think it has something to do with it. That's my guess. So what could I have possibly messed up? I mean, like I said, I've been copying the code so I don't make typos and have some issues like that. It's got to be something with this. Spawn range is fine. What I'm curious about is the wait timer. Yeah, we're good there. Did I make a typo somewhere? So on mob timer, it does instantiate, get scene, random F, player position, mob initialize. I'm wondering why some of them are coming in like tilted. I'm starting to get tilted. There's like this rotate Y. Here's the whole mob function. Have we done anything else? Okay, I'm just gonna copy all of this above. I mean, I don't think I've messed up anything else, but besides the squashed part, we'll keep that. Paste in all of this. I mean, I don't think any of this is incorrect, but let's see. We gotta figure this out. See, like this mob is like through the floor, which is really weird. Also, I think I do need to add back the player, the world mask, because clearly that's important. I'm pretty sure that's what where my problem is, but maybe I also messed up like the... Let me go back to the 3D view for the mob. Like, what's the collision look like? Is that how... Let me make sure like my collision's looking good. Designing the mob scene. Sorry, I'm going back to that. So we have the pivot, and then the collision is on the actual shape. That looks good. The pivot is just for like that thing. The visible doesn't matter. So what's with the collision shape? Maybe I don't have it like a large enough collision. Maybe it's not up like tall enough, I guess is what I mean. I really don't think that should matter. This is weird. Oh no, I don't like having to deal with bugs. It's not what I wanted to be doing. Yeah, the visible on screen really shouldn't matter. Collision shape, we don't have any signals with. That's not supposed to be anything. And then the mob script. on squash, we emit squashed. And once it's off the screen, it's invisible. But I'm wondering why it's being spawned in at a random, like... I feel like maybe that has something to do with it. Let me save this. Let me make sure this doesn't change anything. Let's go back to 3D. Let's test this. Okay, we're not falling through the floor anymore. That's good. Is my player collisions? I mean, it looks like I'm also kind of floating. Maybe my player collision's off. Let me go back to my player. Let me see what's going on here. Collision shape. Get rid of the pivot. It's on the ground. It's wide. I don't... Oh, God. It looks pretty correct. It's attached to the player, not the pivot. The player is the default layer. It's got the right masks. Oh boy. Well, I don't... Anybody have any ideas? I'm open to suggestions. If anybody watching live has any suggestions or ideas, because this is confusing to me. I don't know what I'm doing wrong. Is it the pivot? I don't think the pivot has anything to do with it. I mean, that might be... Might be a bit low. Let me see, where did we do that at? Is that in the game area? That was the first scene? That was in the player scene. I'm trying here. Hang with me. Where the hell is that? Where did we create the pivot? Okay, right here. Let me try that. Does that make any difference? Probably not, but like, let's see. Now it looks like I'm really floating off the ground, which still not, but I guess I'll undo what I just did. Any knowers? Because if not, I mean, I don't want to end this with me just having to fix a bug, but also like I was planning to only stream for 3 hours. We're coming up on 4, so let's see if I can always debug this. This is you can see the outline. It definitely hits the ground. So like that looks good. I think the character is okay. Yeah. I feel like it has to be something with spawning the mobs. Like they're coming in at a weird angle, but I don't know why. There's not much to the mob spawn script. Like I've said a bunch of times, like I copied the code over so I wouldn't make typos, and clearly we got something wrong somewhere. I mean, is the spawn location being like randomized tilt enabled? What's that? If we turn that off, what does that do? feel like occasionally I'm seeing down there, like very briefly. Is there a way to like collapse logs? It's outputting a lot of stuff. See, every now and again, I feel like very briefly I see something. Like it does collide. But why is it briefly? And why is it... Debugging at its finest. These all just look like ground. I don't see anything different. It also happens so fast, and they don't collapse because they're all like different collisions. Is there some setting I forgot to disable for like the follow path, or? I don't think that's it. Right, all this is good. Main point tool. Packed scene. We'll spawn the mobs at regular intervals. Auto start, timeout. We tied that in. I mean, I straight up copied this. I don't... Because all of their mobs, maybe I'll go back to like the very beginning, but like they don't seem to be coming in at different angles. They all are at like the same... Oh, I guess some of them are at different angles, but none of them are like clipped into the floor. Yeah, that was just the angle I was viewing it. I don't know. Maybe I'll have to like continue this once I figure it out. This is frustrating. So I'm pretty sure I did all the like layer stuff, unless I forgot a small step somewhere, but I don't think I did. We added the mob group. Bounce impulse. Yeah, I might have to... I might call it early. Well, not early. I guess I'm calling it late. But I might, yeah, end here and debug on my own. And then maybe just, I don't know, do another small follow-up stream. Maybe this weekend or later this week. I plan on only streaming on Tuesdays, but I'm kind of annoyed at this. I want to figure it out. And I don't want to leave all y'all hanging with, like, only, like, half a tutorial done. But yeah, I don't know what's going on here, so we'll end the stream here. We'll wrap up, I think, which is unfortunate. I'll admit defeat. The I don't know, the what am I trying to say? The bugs won. The bugs won. All right, well, I'm going to wrap up here. This was a fun first stream. I really enjoyed this. yeah, I'm still, like I said, figuring out some technical things, kind of figuring out my layouts, my audio. So, bear with me as I still working through the early stages of all of this and of this new channel. But I had a lot of fun. I'm really looking forward to doing these weekly streams. Like I said, plan on streaming weekly Tuesdays at this time, about 1 p.m. Eastern time for about 3 hours. If you're watching on Twitch, you can follow me on YouTube where all of my previous streams will be uploaded. This is the first one, so there's only going to be this. Also on my YouTube channel, I do have a bit of an intro video kind of explaining the gist of what my channel is going to be about, what this is all going to be about, what stuff I plan on covering, which will basically be this channel is mainly focused on game development and web development, though I plan on doing other things. But yeah, I guess I can quickly talk about next week's stream, which I plan on having the last stream of the month being, which I guess technically it'll be April by then, but I always go my schedules with like the first Sunday or the Sunday, so like next Sunday is still March, so I'm considering next week still like the last week of March, even though it's technically April. Maybe I should change up how I do that, but next week I plan on making the last streams of the month essentially just me playing some software related game. So next week I'm gonna try out one called Gray Hack, which is like a hacking related game, which sounds like a lot of fun. I've not played it. I might play it before, or maybe I might just go into it blind. Who knows? But yeah, I have a good amount of Steam games that are just like coding and software related. So I think once a month I want to try to play those, and then yeah, I'll be sprinkling in some web development streams. I might do a small stream later this week just to finish this up and see if I can figure out the bug in my free time, and then I don't know, do a small stream at some point later this week to yeah, hopefully have this fixed and kind of finish this tutorial, but we'll see. But yeah, that's all I have today. So thank you everybody for watching, and also thank you, huge shout out to Try Something Dev for raiding me earlier. I mean, this is my first Twitch stream, first YouTube stream, first stream of this channel. So I expected to be streaming to nobody, just to be honest, because like it's my first stream. How are people gonna find me if I don't have any previous content? So having that raid on my first stream is really awesome. I incredibly appreciate that, and I really appreciate everybody who followed Emerald Finder, Try Something Devs, Silar Atomic, and Get After It. So thank you all for the follows. Thank you, Try Something Dev, for the raid. That was very awesome. It really helped make my first stream pretty great. And at least, you know what, we made the 2D game, got through that, no issues. The 3D one, we did make a good amount of progress, but hit some bugs along the way, which is unfortunate. Like I said, I'll try to work through that and maybe do a small follow-up stream sometime soon with me completing the rest of this tutorial. But yeah, that's all I got for today. So thank you. Feel free to follow me on Twitch or subscribe to my YouTube channel to catch future streams and all that good stuff. And until next time, I'll see you. Bye. See you next time. Shutting down the system. Have a good week, everybody.